you can get it started. Recording in progress. Finally, we got recorded. Hi, everyone. Welcome. So we're starting from scratch there, but it's all good. All right, but the most important part, I think, for all of you today is if you do this, you will get started immediately. That's all the installation you take. All right. How am I going to talk about this? Six lines of code. If you remember them today, you can run the first inference. And human memory can memorize no more than 7 digits, I think, before you get scrambling. Right? The first time, I can try. I can give you a number if you can remember. Good luck. But this 7 line of code, a 6 line of code, gosh, because we reduce it again, will get you through the entire system. After you do the pip install, you do the runtime. You then load the image. This one is optional. You have your image ready. Initialize the core. You're a programmer, right? You know what I'm talking about, right? Anyone lost? Let me know. Then compile the model. So this model you can download from our repository. We have many of them. We have 300 of them that you can try. You can do like post estimate, detect cat and dogs, detecting Lego if you want. And device name. So guess what else we can do? GPU, right? I talked about GPU. This is it. Switch this. It will automatically switch over. Then this will basically compile the layer, and you get the results by running the model here. This is the inference step. That's it. That will give you everything you need to get your results out. And the most important thing is this is the speed up you need, right? This is the part that will faster, right? It's better than the stock today, so speed up. All right, so if you have any questions, the first tutorial called 101, I forgot. The Hello World.
Hello.
Yeah, so
001.
Yeah, 001. Yeah. That is where you can try all this, okay? Demo time. Are we all ready for demo? All right, Paula gonna take over for here, and you're gonna share the screen to the audience. So
I can share. I can.
You can share.
Oh, because you are sharing. Okay.
Yep.
Okay.
So we're taking care of our live audience as well. Yep. And then we will have a live feed coming from that side to see that again. It's just a technology time. So this goes through the entire server stream and come back out. So this is live here. So to prove this is live, can you delete one arm code and break it? This is live right here.
This is live. So
You have a mic?
yes. Can
Okay.
you hear me?
Yep.
Yes or not?
If not, you can use mine. Mine is louder.
That's better. So
There you go.
in this first demo, we want to show you how you can run this 6 line of code to create your own experience with OpenVINO. So in this case, we are using OpenVINO notebooks. I want to show you OpenVINO notebook has this list of more than 30 notebooks right now, and you can see different kind of models. So in this case, we have a live human pose estimation with OpenVINO. So you can find the model in Open Model Zoo, where we have more than 270 models that are available for you. So the first thing that you need to think about is that we have, the structure, you can see the imports here, but the important thing is that we need to address the directory and also load the model. This is the most important part. So we are using an inference engine. We need to initialize the inference engine. So for that reason, you can see here this part of the code, this command line. And the second step is that you need to read the model. When you read the model, you have the input and the output of layer. And you can compile the model in different devices. That is the magic that OpenVINO has, that you can compile the model in different devices. You can use CPU or GPU or other devices that also Raymond mentioned today. So you can see here how you can get the nodes, and that is important because you need to know the nodes to run the post-processing information with the model. And let's see. The rest that I have here is the post-processing information. What do you need to do with the results that you already have? In this case, we are getting the heat map, and we need to find the poses of the human. So we need to process that heat map. So you can see that it's like a simple thing that in computer vision. So I don't want to go deeply there. So draw the pose overlays, and the main processing is just call the video, open the camera, and you can see this inference live using just the webcam. So we are trying to create with OpenVINO on notebooks, we are trying to create a great tutorial for you. So you can go there and you can see how in a simple way you can use a model and you can prototype faster your idea. This is one of the things that we want to do with OpenVINO notebooks. And you can find this kind of thing that you can connect with a hardware, you can connect with new models. So let me run this model. So, and you can see here my face. So, and also, okay.
You can do the screen.
Just
the screen.
Yeah,
Yep.
move lead.
And it works with 2 people, by the way.
So you can see here the frames per second that we have. So, and I really want to show you how you can improve the performance of your model. So one of the important things here, as I told you, you can compile the model in a different hardware and you can see how you can increase the performance. So we will talk about supported devices later, but I want to show you how we can change the performance of the model. I want to use auto. Can I use auto, do you think?
However you like.
Okay.
I don't know what you're doing, but that's good.
So
That's kidding, I know.
is that
We built that together.
so this is something that, because this is something that we can talk later, but here in devices, device name, we can put here GPU.
Okay,
Or
before you
more.
do that, let me help you a little bit. Make this go away, because it's like getting in the way. You, good.
Okay.
And then make this bigger, right? People want bigger phones, right? It's like out at the back, I cannot see it. 125, good. Still glinting? Okay, at the back, I know, I saw your eye. I can't see the damn thing, sorry, I'm sorry. All right,
it's fine.
sorry,
It's
sorry for the
fine.
language, but there we go, let's keep going.
So let me put here auto. So what is the meaning of auto? Raymond will talk about that later, but we can keep the performance in between CPU and GPU. And this is one of the new things that OpenVINO has for you. So you can increase the performance, you can make this model run faster in your computer. So let me, I will start the kernel. Let me see.
Kernel, restart, and
run on cells. Thank you.
that's the magic button. If anything goes wrong, always use that. You'll clear the cache.
So remember that I have 60 frames per second. So right now I have more than 100 frames per second.
For the contrast, you cannot see
Yeah,
that.
put some and
Okay, see the frame per
Okay.
second sound? All right, contrast enhancement. Fat jokes? Come on, guys. I'm a CV guy. What do you expect? Sorry. All right, at least you cut the. So with this frame per second, think about applications. Anyone try to Kinect before, right? Like, that's a Kinect. Well, here, Kinect, right? And that was the first problem I was solving back then. I was the CTO of the company. Check my fingers. It was so hard. Now with this toolkit, you can download the model and you can brute force it to run on better hardware because you don't have time to optimize and you can get the results out immediately. All right, let's keep going. Questions? Yes.
Could you? Okay.
I'll run to you. Hold on.
Because we have the mic here. Maybe you can use the mic.
What hardware are we using? Oh.
Second.
What hardware are you using?
Gen 12 baby.
Okay, this is a Gen 12,
Yeah.
and we have like an iGPU.
You can show them the.
Okay, I can see I can show you the performance.
Yeah, you can show them the activity bar. I forgot. Yeah, yeah, right here. No secret, right? And you can see where I'm not even tapping onto the full performance just now. You can
It's
run
just
again.
It's just the 25%.
Yeah.
So I will run again because you can see here when I run how we are transferring the models in between GPU and CPU. So let me show you. Oh my God. I will stop this and restart all.
Yeah. So this is something we'll talk about. It's called an auto plugin. But let's look at the CPU and GPU, what's happening.
Okay.
You see GPU is still waiting and then kick up, right? We actually handle that delay for you. So when you click that button, inference started, and we just like ramping up the GPU. Once the GPU is like, I'm ready, we switch over. So that helps you on the user experience because most of the time you click that button, load screen, loading. No, you don't want that. So this is what we're doing. And you can see we actually balancing the workload that way too. And in the new release coming up, we have more release coming up. We even have better load balancing. And we can talk about how you can do load balancing on CPU better too. You can have like throughput mode versus latency mode, things like that. But let's not ruin the game yet. We have more to show, okay?
Yes. So this is the message that I want to give you right now with this demo. We need to continue with the rest of optimization tools that we have. And so let me continue with the presentation. I will stop my desk and so.
All right.
So the next topic is,
This is you and me.
I think this is mine.
Yeah.
So
Switch.
there's a question. We have questions?
Oh, I have to turn on the mic. Hold on. Is it on? Try tap on it.
No.
One more time.
One more time.
Screen.
Okay, so when you choose the auto mode, I saw that it was just using the Intel CPU. So whenever you choose auto, it's not going to choose all the hardware, just the Intel hardware, right?
That's an extremely good question because it's a plugin architecture, right? So right now our team been choosing the Intel one because we fully support it. But I'll say we can go beyond because we also have ARM, for example, as an open source effort. You can try. We also have that VPU that some like other people maybe actually have a different version with repackaging. So right now the way it works now is first go to CPU because I know your CPU works. You're running your operating system now, so it'll run. Then it will discover the rest of that, let's say the list of hardware. And as I said, it's a hardware kind of like a plugin. So depending on your system, our team can help you to enable the list. And again, it's open source, by the way. Did I tell you enough that it's open source? If you're hungry enough, want to change it, go hack it. And that's what we're doing at Google Summer of Code. We're hacking the whole OpenFino repository now with students, if you're interested. If you're not students, also feel free to try. All right.
Let me continue with this.
Let's keep going.
Okay. So, it's another way. Sorry. Okay. I told you about the OpenFino notebooks, and you already have also access to these slides. So you need to maybe download the slides, and you can see here like this square, green square, and you can access the link in this green square. So you can see like clearly all documentation that we already have in OpenFino notebooks. And I also invite you.
Scan the QR code.
Also, you can scan the QR code. So, we invite you also to contribute to our repository. If you see that is interesting for you, that you can contribute with a specific model. So also we have the contribution open for externals. So, we made this. Also, I invite you, if you want to have prizes, to run this demo that I run today. So we have today 5 exercises. So 5 of those you can get prizes. In the other 2 are demonstrations.
Yeah,
So
special prizes.
maybe a special prizes for the final. So I invite you to do that. So the next topic, so we have here a break, but maybe we can continue talking.
No, break.
Yes, do you want to break?
Quickly, questions, Q&A. or BioBreak. Yes.
So Intel has a accelerator library called math1KLDNN. So does OpenVINO tap into it? And is that how it is passed or?
Pretty much the one API. That's exactly what you talk about. Some of that is we are interconnected. I'll say the Intel software. Yes, some of that. Yeah. You can almost think about this is like easier interface unless you want to go with the lips or you want to have like a product like documentation and all that is a lot easier to go with right now. You can go that way too. I'm not against any of that depending on use cases, right? If you have a very specific acceleration you want to get done on a specific way, you can also do it in C++, by the way. Yeah.
The next topic that we want to talk today is about the optimization tools that we have.
Right.
This is a pretty important topic.
Hard as well. Yes. Open, can hear. TensorRT. Oh. I should bring my boss to talk about this because we talk about this quite a bit as a business, right? I'll say OpenVINO, you have access to this portfolio, right? You have choices, right? You have all this like CPU, GPU, all that, right? Fundamentally, I think vision-wise, we just want to accelerate. We want everyone to have the fun, right? Having the acceleration that you can do on the optimization side. From an Intel perspective, I think the way we open source this right now, they open source eventually, it's just like giving that community that flexibility, right? It's a little bit more flexible. Like you have a choice, right? Let's say you want to switch hardware. Well, you can do it like overnight. The other one, you have to do it, but it's just up to your bandwidth, right? And at work at Intel, I think also the support is quite important because it's not just like you're buying the hardware. Once you get on the field, it's a completely different game. So that's the other thing that you notice. The support we're giving is quite extensive, right? So, and then performance-wise, we have some plot you can look up. So I don't usually discuss the performance here. Just like it's left to the scientists, right, to discover what is the best way, right? But we definitely benchmark everything you can see on the website. Sounds good? And if you have any further questions, my LinkedIn is always available. All right, so this 10 minutes, it's up to you if you want to, let's say, ask more questions or we can keep going.
I think that we can keep going. What we do prices?
Prices?
Okay, we can maybe make the prices for the people that already made the pre-work. So who made the pre-work? You? So we have 4, I guess. We can show the link.
Right.
So we have a discussion thread in our repository. So we saw who is
The first one.
the first one?
PF video.
PF
Right.
video is here.
Who did that?
Nobody. Okay.
So he
next
did it
one.
and not, he just left to do your homework. I love it.
Next one.
Okay. Yes. AC AI
Big
the
program.
programmer. Not here. Okay. Good.
Next one.
Next one is
Japan. Oh, this is the next one. Can I see?
no. He made a lot of stuff.
Oh, okay.
AI did make a lot of stuff.
Could be a
Okay,
virtual
from
one.
here.
We have,
All right. Well, congratulations.
Okay, enjoy.
Yeah.
Maybe you can get a great performance with edge devices.
next one. Here.
You?
Yeah. All right. And for people asking questions, I'm going to give a t-shirt as well soon. So don't worry. There's like always a way to get something today.
You?
Yeah. It's right there.
Stephanie.
Here.
Stephanie, there.
Here.
They did? It worked? It didn't work? Support. So that's how Intel do it. Support. Yeah, right there. Give 1 second. Once we get this support done. Adrian.
And the
this-
next one.
Next
the
one.
next
one, yeah.
Let's see. Next
Who
one.
did it?
You?
You?
Yeah.
Okay.
So thank you. Thank you for making that. So
No more.
no more.
Okay.
So I think that I can continue with the tutorial. The next topic is difficult. So who have made anything related with quantization? Okay, you know a lot more than me. So
flicker of the.
OpenVINO has a great tool.
Use Chrome.
Chrome, yeah.
Don't use that. There's a Firefox. The Chrome. Safari. No. Chrome. Try Chrome.
So OpenVINO has a lot of tools that can facilitate, the quantization. So and we are looking to create a faster models that are able to run in small devices at the edge. And this is one of the things that we want to do with optimization. So we have this goal is like you can make your model run faster and take less memory. So when we were talking about optimization tool, we have 3 general optimization tools working with OpenVINO in the OpenVINO ecosystem that we have. But we have more than those optimization tools. If that is not enough for you, we have another tool that I want to talk at the end of the tutorial. So the first and the simplest tool is the model optimizer. When you think about the model optimizer, it's a cross-platform command line tool that you can make the transition in between training and deployment. So you can create optimization using just the command line. And this is just a command line that you can change the precision. So you could have like a native model with your choice framework, and you can change the precision in between Floyd 0.32 and Floyd 0.16. But also Model Optimizer is the tool that OpenVINO is using to create the OpenVINO format. And the OpenVINO format the name is intermediate representation. That is the name of the model in OpenVINO. Intermediate representation creates 2 files, one with the architecture of the model, XML, and the another one with the weights of the model, the binary. But Model Optimizer is more than change the precision. So we are able also to fuse some layers. And also we are able to reduce or eliminate some layers, as for example, dropout. So in that case, we can create smaller models. So when we have this fusion, so you can see like a simple model, but we are keeping the same performance of the model. Model Optimizer doesn't impact the accuracy. This is something super important. We don't impact the accuracy of the original model. So, do you have anything else to add to the Model Optimizer? I think that I have one thought, but
yes.
Okay, this is a great question. So we have.
What's the question?
If we are working with PyTorch.
Right. We validate a lot of models, like what you said. Is it like validated? So 2 ways to do it. One is really run the code and you see if it'll fail immediately. So that model optimizer code, you just like run that line. It will show you which layer is not compatible. The other one is we did our benchmark, right? So we have a repository with 300 model tested. We benchmarked and tested, so you know it guarantee will run. So we'll talk about that in a couple more slides. These are the preset that we spend a lot of time to guarantee it works, and we guarantee we support them over the lifetime too.
I think that this is a great question because I think that but this is more related with quantization instead with optimization. So we also have the web page that you are able to see which layers we are supporting with which specific devices. So we can quantize, but this is a different topic. Some layers for CPU, I mean, almost all. Some layers we are not able to support right now, but we are working with that and we have that in the roadmap. And another devices. So I will show you, just keep that in mind. I will show you the supported devices and you can just click the link and see what kind of layers we are supporting. Related with frameworks, so we are supporting, or maybe we can make the transition in between different frameworks and OpenVINO format, the intermediate representation. PyTorch also is in the roadmap. We need to make the transition in between the conversion, PyTorch to Onyx, Onyx to OpenVINO. So for now, but we have that in the roadmap to make that directly. So I want to run this. This is a funny demo that you can. Okay, go ahead.
Yeah, sorry, I have a question about the kind of implementation. Is it linked to a device to target, or is it agnostic to the target?
The precision, yes, you need to.
The IR, is it when you create this IR, is it linked to, for instance, the GPU specifically, or is it
Is
that you will export?
so if you look at the flow is, let's say Onyx, right?
The camera. Yeah.
The camera. Go. Oh, geez. Yeah, don't see only my belly. The flow will be like Onyx, for example. You have that model. You go through that pipe, the model optimizer, IR. The rest you don't have to think. It's all supported.
Yeah, but my question is, when you optimize it, export device at this point, or is it after that? You have a runtime that will.
There's free stuff. There's like post optimization that you can target to the device too. You have the curve again. We have that in the later stage where we show you the pod where you can target, let's say, the GPU, for example. We have a specific way that target to that. That's a coded post training optimization. It's actually in there. Yes, it's happening. It's one of the very long notebook that if you manage to understand that, I'd be really surprised. But we try our best to document it because it's quite in depth. Okay. And for the virtual audience, I see they have questions too. We can answer one of them if there's any.
I want to add something maybe before to continue. I want to add something with the model optimizer. So you can change the precision. If you change the precision, for example, you have FP32 and FP16, you can see the differences in between this precision in our model optimizer with the native model. You can see the differences. But if you have precision 32 and 16, OpenVINO, you don't see a lot of differences in the speed related with the speed in CPU. But if you use FP16 in GPU, you can see the difference. So it's much faster, the model if you run in FP16 in GPU. And this is the preference to use the preference precision to use in GPU,
So
FP16.
to make the life easier, we make a little table, like a support matrix. So then you don't have to guess. I did the guessing before, so we put it together. So, all right, let's keep moving.
Yeah, so the next thing is the
Demo again. Yep. But put a good summary first because a lot of information flew through your head. In short, I think one thing you really learned were there are many tools at different stage of your development. If you're, let's say, early stage, you just get a model, you want to get it faster, model optimizer, kick it off. That will guarantee you get you something, right? You don't see maybe 10x faster and all that, but it'll get you a little bit better into the game. At least you can deploy different hardware immediately, like the GPU use case that you just saw. Then if that's not enough, oh yeah, we have more. We have post-training optimization and a lot more that kicking in. That's the thing that we'll talk about next. Stay tuned because those are really like hard. Yes.
We have question from the virtual meeting. Could you confirm that optimization of a model don't affect the accuracy?
Accuracy, yes. So the step one, if you stay on the FP32, there's like the same that pipe. So far, when we tested, given what we have in our model data set, it should be as close to identical, right? But once you're doing quantization, let's say, well, come on, like we're switching the accuracy, right? So that is the time that you have to really validate your model. But we learned that the accuracy job won't be, let's say, really dramatic because we have ways to tune it specifically to each layer as well. So there's fine tuning you can go. I think someone's nodding. Yeah, it's good stuff, right? Yeah.
Remember that we are making rounding with this changing the precision. So we are not making quantization. For that reason, the model optimizer doesn't impact the accuracy.
Yep.
But the quantization could impact the accuracy, but we have some solutions for that.
But even FP32 and 16, there's still less bits. I cannot guarantee that, right? Depending on your use cases and models. Yes. Give them t-shirts.
One thing that I noticed is when you guys do this information, are you guys using built-in libraries for Or you guys?
We have our,
So, I mean, maybe we need to repeat the question for the people that is connected. I don't know, maybe we can fix the mic for them. So we have in the pipeline, you have the pipeline of your PyTorch and TensorFlow. We will talk about that later. If you have the training pipeline, we have the options that you can make quantization using your own PyTorch pipeline, training pipeline.
all right. Again, a lot of people ask questions. Again, we'll give you a t-shirt for real. Okay, no jokes. We will give you all the swag today. And thank you for participation. It's actually, again, yes. In 8, yes. And then I think people ask about in 4 and all that. I don't know yet. You can try, I think. Yeah.
In A is for quantization, and also we are supporting for bits and binarization also for some models.
Yep. All right, so let's go through the demo. I think to prep you, let's hide the bottom bar if we can, so that it's not showing that bar.
We can see them.
I mean, this is a new computer.
Hey, Ray. You can see it.
I can, let's just keep going then.
Okay,
Yeah,
so, okay, it's
for now,
fine.
yeah. Yep.
So this demo is really good. You can just work like Photoshop, major Photoshop. We are using U2Net, PyTorch network, to make the semantic segmentation from the people, I mean the object that is in the first plane of the picture. We are making the import. This is the same structure for every single notebook. We have exactly the same structure. Imports at the beginning. So we are importing here all things that we need. We are also we have different models that we are able to run, and we need to select which model we want to use. So at the end, we have here the paths. And remember, PyTorch is not directly integrated with OpenVINO. So for that reason, we need to do the conversion between PyTorch to Onyx and Onyx to Model Optimizer. Remember that the goal of this demonstration is show you how Model Optimizer is working. So load the model that is normal. So we have here normal stuff. So using the UNet model. So here, so we need to convert PyTorch U2 to Onyx and intermediate representation. You can see a lot of this IR. Remember that IR is OpenVINO format, intermediate representation, OpenVINO format, XML, and binary file. So, okay, so we are converting here. So here is the cell that I wanted to show you today with this demo. So we are changing the precision of the model that we have in FP32. We are changing to FP16, but also Model Optimizer is managing right now the main values and the standard deviation. So making the pre-processing for you. So you don't need to worry about the pre-processing of the images that you need to put in the model, because Model Optimizer is making that for you. So, and this is a single command line. So let me show you how this is running. I will run all cells and you can see the result.
So this one's cool because, you know, you can cut the background out with this one. So now you can bring the dog to China, from here to China.
Yeah, so.
It's kind of cool. And you can do a lot of memes with this, like a lot of applications behind it. And this actually used extensively in imaging a lot, like medical imaging. You see a lot of people do this for even more serious things. Yeah.
So something that I want to show you is the inference time that we have is just 0.37 seconds, and we have 2.65 frames per second. So it's not so bad. So we have a good inference with this, and we are working with a huge image. So this is also something that we can do in our life if we need to make additions.
Later we'll show you the benchmark, like the before and after, a little bit better. Like right now, like, 2, what does it mean? Well, you see. Before it's not 2.
Also,
Even 2 is not easy. Yeah.
Also, we invite you if you want to train this notebook, right, with your photos or your ideas and post that in our repository. Just follow the exercise that we have there.
Yeah.
So you can continue with the presentation.
All right. I think a lot of you already saw a lot of hard things. Let's go easy again. Yes, questions?
The pre-processing, is that also supported in the Linux or
Pre-processing in what sense? Like the
I think you just subtract the mean and
oh, the pre-processing step. Oh,
yeah.
So it's just a prepping the neural network have that layer that's like take the input in various size and all that. The pre-processing is just reshaping things to fit.
So it's
That's-
not part of the graph, so it's
No, it's just what we do additionally to show you how to use the network, right? It's just a step I always put because you guys did YOLO and all that. They're all different sizes, right? Like you don't just dump the image like a 1080p in it. So you have to like fiddling of it. So we're just showing you the code, but in Intel, the OpenFino have a pre-processing pipeline that accelerate that part too. I don't talk about it right here, but it's somewhere in the code that I should read more, but I'll show you again. It's there. I'll let that roll. There's a train behind me, wait. There's a train behind me. Okay. It's still going. Oh, done. All right. Yes.
I have a general question about the
Yes.
For edge devices, is there a way to make not the speed of the latency, but like the RAM usage, put on more small devices?
How small? Very small. Better.
I would say edge devices.
So just a good example of that is if you look for Open CV AI Kit, one of the company does spatial computing. I keep forgetting the name, Lasonius, then the OD, that's a camera. We actually supporting it, right? And the device does all the, I don't have cell phone right now, look it up, they're a partner. We're actually supporting that device. So that smart camera have the GPU in it. And when you're deploying the model, it will load the model to the camera. And the rest is history because it gets accelerated on hardware level there.
When you deploy, you don't need the whole protocol.
You will need
You
some,
don't need the framework.
it will be like, that one's a bit of a tricky one. So we have a couple partners that like, for example, AD-Link is one of the example. Got you. All right. AD-Link, for example, they have that tiny board before that, like a SoC, everything in one chip, right? That was like 10 watt, and then they have that GPU built in as well, right? So there are many examples of like depending on use cases, and the OD doesn't have an operating system on it, so it's basically it's like a host device where you basically load the network and do the processing. Oh yeah, that'd be nice.
Great.
All right. I know it's hard to deploy those, so we actually have a lot of examples I can show you. And I actually contribute to the OD repository, one of the tutorial I wrote. I did it, the flower one. It's pretty cool. Stay in touch. I can show you a lot of cool stuff. Sounds good. And get a t-shirt. All right, so for the rest of that, I think, let me wake all of you up. I know it's right after the lunch. It's very tiring, it's hard. So let's talk about this tool a little bit. I'll help you a little bit. So just look. Yep, I'll get back in the camera. Sorry, guys. All right, come on in. Have a seat. So I think this part, I want to tell a story how hard your life will be without this. I try myself. It's a nightmare. Anyone trying to do quantization ever in your life? Anyone? You know how hard that is? Hard because, okay, first, okay, just forget about just like what quantization is. You know rounding error can kill your bank if you want to do it wrong? Missed by 0.111 somewhere. It will never find a bug, but it will show up in your final model in some weird way, and you will never find it. Same thing for, let's say you're doing optimization, you parallelize your work, race condition, flipping bits, you're in hell. I'm sorry, that's the word. When you're coding on those, That's why this kind of like tool and steps is like oftentimes as a developer is a go-to, right? When, let's say we propose this tool, again, you always think about this is like, you already have a data set. You already did all the work, right? Remember my dinosaur problem? Actually, Stu was not here. I talked about dinosaur problem. I'm trying to find bones from a desert, basically. Oftentimes, we will have a data set. Okay, and all that, right? But the problem I'm dealing with right now is that's still like, I remember I say I have a PyTorch model, I run through the model optimization. It's great. It gives me some speed up. If I want to go further, I have to optimize based on the data set because I have to ensure I don't drop the accuracy wrongly. And that's a tool it's great for. When you're doing this optimization tool, we have accuracy aware compensation. Now, what does it mean? In a fancy term is try your best not to trim it too hard, right? Because quantization means, for example, you have a number that's like, let's say 1 million with some precision in there. And we try our best not to mess around with certain layers. You can define which layer like they're sensitive to the output, and we'll try to optimize it around those. And you don't have to do it. That's the good news. That's why we build tools, because a lot of customers come back to us like, can you do this faster? Without engineering effort, like, it's impossible, right? You have to read all the source code. So this is like a set of tools that you end up with the quantized model with the FP32. And this tool set, you can just configure this. For most of you, it's unlikely you will have to face this problem, but if you learn it, it will look so sexy on, so good on your resume. Why? This is the holy part that actually you save a lot of computation, because a lot of your hardware, regardless like what hardware you get, this is always faster, right? You have like, you can use different kind of pipeline acceleration techniques, right? Because fundamentally you have less to compute, and your hardware is always faster to compute this than floating point. Depending on your hardware again, if your hardware has absolute no like compute unit for integers. So I wrote this demo a long time ago. So I gotta show you everything I've done. This demo is from TensorFlow back the old days. So I wrote this about 2 years ago. Anyone did TensorFlow demo ever? The tutorial? Yes, right? Tutorials? That's the first tutorial you ever learned. That's when you pick up machine learning. That's the first one. This is the one that people always like, the flower demo. If you ever go to a conference, it's like flower demo. It's like, why? Well, that's why. This is the first tutorial, guys. What do you expect, right? The first thing you learn is this is the thing that you show every day. So if I right now go to this tutorial, I will recommend all of you put up your cell phone, scan this code, so you can see on your screen at the same time. There's no way you can read everything on my screen, but you can try to like go through this super long tutorial with me, okay? And I'll go very slow, okay? I speak really fast in general. I'll go half the gear. Is it ready?
Can I share my screen?
Yeah. Is it working? You tried before?
Yeah.
Yes, good. Thank you, God. Yeah, you have to run it before, right? That's good. So I'll stand behind this podium and explain the whole thing. Let's run the whole thing. Let's run now. Yep, do full screen. Yep. Do full screen. Yep. Ooh, mouse. All right. Are we seeing this? So again, before this happens, oh my God, can I get this out of the way? This is blocking me.
No, it's
The other one, pre-training one here. This one. Yeah. So let's look at this one first. So again, I borrowed this from TensorFlow, quote-unquote, because it's Apache 2. You know, anyone knows Apache 2 is like the best license ever. You can do whatever you like. All the code I do here is Apache 2. So if you copy and paste it to share your friends and make money, I'm very happy. That's what it means, okay? So let's go with the code. Again, I'm not gonna teach everything, but I'm gonna focus on a couple key hard items. First, this is the training step, right? So the way this works is it will pull the flower kind of like pictures out, and then you want to train neural network to do classifications. The reason you see this a lot is like it's super easy to do if you use like TensorFlow. Again, there's a train behind me. I'll keep going. So the way it works is we want to recognize 5 classes. The 5 classes are daisy, dandelion, roses, sunflowers, and tulips. So what this will do is it will load the data set. I'm not going to show this, but I'll show you. Whoop, run all this. Oh, this is running already? No. Yeah, it's running. So it will show all this data set, right? As a human, we took a lot of pictures of flower, surprisingly. So if you go on Flickr, you get lots of them. And then they label it. So we have a lot of data sets. One thing you notice is you get roses, but you have something in the background like this. You have all this weird things that represent each of these items. And apparently that's just roses, right? So there's some bad stuff in the data as well. So again, this is a play. I got a toy example, but some of them are pretty good. So what this is doing exactly is, oh, I can't see, this is in my way. Yeah. So what this is doing exactly is we want to train a neural network to recognize 5 classes and optimize it using the Atom. And what happened when you're doing this is, it's actually quite straightforward. You train the model, right? You're trying to accuracy doing all this together. But what it's doing slightly special is we're doing something called data augmentation. You know what that means, anyone? Right? So in short is when you're training a data set, you never have enough in the beginning. So you want to, let's say, add a little bit of rotation variance to it. So this does all this, so you don't have the problem called overfitting. And more importantly, I think the key is once you get that output, what I'm showing you is this step. OpenPheno is where after this step kick in, right? You get the model. Let's try it. Someone asked me, how do I run it on an embedded device? This is the step we take. You train a model and then do the model conversion again. And once you finish the model conversion, what happened, you will get is like a IR model, like what we said last time, and you run it through it. And since the other one's running, I'll wait for it. But most important is I took the last photo. You'll see a dandelion. I took that photo myself and it worked. It has 99% accuracy because that's a very simple class to recognize. So this is a toy model that you play with a lot, but fundamentally, if you're using TensorFlow, you end up with very similar workflow and doesn't change very much. Now I'm waiting this to run. Any questions so far? And then this is running on my CPU only. You don't even need a GPU to run this fully. So this is locally CPU crunching through this. And it'll take a minute or 2. So this part, I think a lot of you may already seen today is having this step already give me some boost. And remember I said, well, if I want to get that really amazing frame rate, this is what this is doing, right? Once it's trained, it will go through the optimizations and it will load it on both CPU and GPU today. Remember, long time ago, people say this, you can only do maybe a couple frames. Today, we're going to show you it's over 10,000 frames per second with this. And we're going to see. And it's still loading. But let's talk about the tool. Once it's finished training, what does it do? So for beginner, I think I will avoid doing from scratch. Read this example. The tool already comes with our library. So these are the tools that are important. Each of them are documented heavily here, but these are the APIs that to remember. Remember the first thing we learned today, this part? Remember the 6 lines of code? Never been the 6 lines of code to memorize. That's all the import. But these imports, okay, you do it. What does it do? You have to set up in a way that it knows this is the configuration. You have to know, okay, where's the targeting, right? And what you want to do? I want to do performance-based, not the accuracy-based, right? So these are the preset. It's almost like a click of a button. If you're doing this right, you basically download my notebook, copy and paste as much as you can. As an engineer, number 1 rule is don't do it yourself. Copy and paste. Go on Stack Overflow, right? You don't want to do yourself, right? And then after you have this, let me show you. What this will do next is okay, we preset this performance-based. So this one, I will not worry about accuracy as much. Just FYI for all of you. The data is not that great anyway. So I make the decision to say, I just want to recognize the flower. My use case may be on my Valentine's days well, not Valentine's. And then first, for my wife, I can just get married. I keep remembering that just last month. So if I want to say, do a surprise to my wife, maybe say, okay, here's a flower. Here's a door, smart door. pull up this flower, unlock something for her. I can build a demo like this immediately, right? It's like for fun stuff, okay? But let's see what happens when this keep running. And one question people ask is, does it take a long time to do post-training optimizations? Answer is not that bad. Not as bad as training. That's why we do this a lot. You don't want to retrain your model. And let's see what will happen when we run this. I want to show you the optimization. Like this is all the steps. Well, I want to show you the results and go back to the steps because I think it's finished loading. That's the picture I took. So this neural network able to recognize my flower with quite good confidence. And I'll show you the before and after as well. Like even with bit like FP32, it doesn't affect the accuracy as much because of my use case is a little bit simple classifying. But let's look at the speed, what happened. So right now, I'm gonna show you, this is on my computer. I have my CPU and GPU. By the way, this GPU is amazing. If anyone ever tried this, you have to try it. It's almost like, it's like you have extra pair of CPUs, right? Everything together. And if I'm running this just for the CPU, I'm getting 2000 frames per second. I do it again, quantize 5000. It's like free lunch, close to, with some performance drop, performance like accuracy drop. But if you're doing this with CPU and GPU, with quantize 10,000 frames per second. What did we just discover? We discovered a tool that will save your life when you have a demo tomorrow. Because now you don't have to retrain your model. You just have to pipe it through this. Very likely you will get a good outcome for your test use cases. Again, take a sort of grain of salt. Make sure that you test your accuracy, benchmark it, make sure you don't doing something wrong. But with this tool, I think the bring home message for all of you is the reason your inference code is slow on CPU were it was not optimized. And this is how you do a couple lines of code using this tool. You can get like a lot better performance out the box immediately. And if you compare this to the original one, is barely 2000 frames per second. My case is close, right there. And this is a very much like my recommendation tool for a lot of you, because I'm not the only one showing you this, because we have customers using this for smart city use cases. Because it matters once you have the box in the box. You don't have access to huge cloud resource. You want to deploy it. For example, I have a use case from one of our partners. Guess what they're doing? Anyone go to shopping mall? Yes. They have camera. We know. You know why they have camera? They want to know where you're doing, and there's security reason, right? One of our partner, what they did is take the infrastructure. They put the tiny, well, I'll say the mobile processor we have, like one of the i5, i7, right, the Tiger Lake back then, and put it into the box and run these detection. Back then, maybe they only get 5 frames per second, something like that. For tracking people, it's not that great, right? You may drop out, you have like maybe some problems because you want to make sure that you're tracking correctly. So you can kind of predict the traffic flow. Why is it important? Because in, let's say, shopping mall, the rent is different, right? It's like you have like the top floor and the bottom floor in a high-rise building, different costs, right? They actually can predict the flow of your customer, and so then you can really adjust like promotions or making things better for the user experience. And then by doing this kind of acceleration, guess what? They have such a small device. You don't need a huge machine, and you can deploy on the edge. And that's exactly where the value I think you all have to think about. Like doing something code-coded, even post-training, you still can get performance that's fulfill your use cases. And of course, I'm talking about human tracking as a slightly oversimplified, but even your very complicated thing with, I work with GE healthcare. You guys heard about healthcare system, GE? I hope you don't have to do X-ray and all that in your life, but I think you should do health check. We're getting old. But the machines they have there actually is our partner. They also have used some of that quantization work that you're seeing today. And today we're going to show you a little bit of that. Paul is going to show you an example of something extremely serious. I hope none of you get kidney stone in your life, okay? It's the most painful pain ever. But we're gonna show you CAT scan. Is it CAT scan or yeah?
Computational, yes.
Yeah, so we'll scan and show you how to do segmentation, right? It's coming up. But go back to this, I'll go through the code a little bit. Again, you know the why. I gotta walk through the code again. I'm sorry, guys. Like, this is a technical conference, so can I do the 5 steps? Can we all help me finish this quickly together? Step 1, load the model, okay? Step 2, initialize the data loader. What does it mean? Follow the code. But number 3, I think this is very important. If you want to do it with accuracy, like people ask me, do I drop all the accuracy? Switch this flag correctly, so you're not killing yourself there. Now the next step, just initialize the engine, create a pipeline, and execute it. And this doesn't take a long time. Like, it didn't take as long as the training just now, right? The post-training step is really fast, actually, in general. And then next step is, of course, compress your model and save it. And what you have now is, instead of the FP32 model, you have the in8 model that you can use. So in terms of workflow, again, data set you have and all that, what you need to do is create this pipe, drop the model in, get the in8, run the inference engine the same way, just switch out the model. I didn't change anything. The code is identical as FP32. You're just switching out your model with the in8 one. And that's all the code you have to remember to run this. And the rest of the setup you can copy and paste from this. Make sense so far, everyone? Okay, it's not too bad. And the rest you don't have to read. Like, you don't have to read like extensively. But this chunk, read it carefully. This is the most important part of this tutorial. And if you want to watch more tutorial, I'm doing a workshop again in about 2 weeks, as I said. So I'll talk about this again. Questions? Yes. Well, my God, so many. One at a time. One at a time. Yeah, he's the fastest I saw.
I've got 2.
Yeah.
The first one is, you said before, very likely to get some optimization, but can you name the case where this is going to get
I have the country.
So you said before.
Yes.
That's very likely to optimization.
Yes.
Maybe the situation with this is not.
This is one question. The
Yes.
second question is, you said that the processing, the pipeline, the extra optimization that you're doing is fast. It's not going to take any time. So do you have baselines? Can you tell us more about how long it's going to take?
To the optimization training stuff, right?
Can you repeat the question?
Yep. Oops. Oh my God, this one's loud. 2 questions. One is like, when I run the model optimizer, is it guaranteed that it will be faster? Can it be like a, oh my God case, it get worse? Second question were, how long is the long, right? I just ran it, by the way. That's how long, by the way. That's the short answer. I just ran it live. It couple minutes. The whole post-training optimization step is minutes. The training step, I'll actually train a model from scratch. So again, let me clarify what just happened. I took the model from the internet. I trained the model from scratch just now. It took forever because I trained from scratch, right? But after training, I have that model. I go through the optimization tool. That takes less than a minute, the entire thing. So a minute, I think we can afford that in general, right? We're talking about minutes, not days, okay? And that's the answer of that. The first part is the case of where it will be slower. Benchmark-wise, usually we start with 1x, 1 point something x. I haven't seen a benchmark that's 0 point something, but it's possible if you do something wrong. Maybe it's like the overhead versus, because usually the x is compared to TensorFlow runtime versus OpenFino runtime, right? If you do it wrong, maybe in some way, maybe, possibly, like I shouldn't be guaranteed everything is perfect in this world. You're a developer, right? How many times people do stupid things, including myself? I do it, right? So that part, like I would say, extremely unlikely it will be slower. Otherwise, we won't be shipping it today, right? On par, very likely, worst case. I would say worst case. And if you have like less due to overhead for whatever reason, file a bug. I read the bugs before. I have experienced that once because of the memory issue. That, for example, it's a bug that I find out from the internet myself. I was like, oh, there's a bug here. Like I was like before, right? Then that is the situation. Sounds good? And yeah, it happened once, but we fixed it. All right, questions? One at a time. Oh my God, you're awesome people. One at a time. Sorry, I got to go left or right. Is it okay? I remember your face. Yes.
So my question is, from what I could understand from representation, I'm talking about 8-bit conversation. But also you mentioned before binary and quantization maybe
That is with another tool.
with another.
Yes.
And no sub-byte quantization. Because in some, let's say, architectural extensions like now, there is support for 2, 4, 8 bit instructions.
I know what you're talking about. Yeah.
Those are two places the question you make because in some cases when you need to mix precision and quantization, those get a non-linear kind of latency profile.
Yes.
So sometimes you use like 4-bit, 8-bit.
Yeah, exactly. 4A, I talk about that. Yeah.
Faster than 2-bit, 4-bit, for example.
Yes. Right.
So my question is, you limit yourself to 8-bit, and you have this possibility of doing this quantization aware.
I was going through the forum from Intel. So by the way, if you all have like really hard question that I don't know, like my brain is only this big, right? So I have an bigger brain called Intel support. I gotta keep saying it for a good reason. I read the thread on that. If you don't mind, search for me. We talk about the info support at one point, like what you said, the mix beyond like either binary or innate or in between, right? There's a thread talk about this because TensorRT I think is doing, I forgot, like something like competitor was doing it. We talk about that problem. Let me follow up with you exactly on that. I don't have an answer in my head immediately. I don't want to say it wrong. That's my answer, right? But that means he's really smart. He knows those like really edge cases, which as a developer, you should be aware of. There's no, yep. I'll get back to you. Is it okay? Great. Yep.
So this post-optimizer tool is part of the standard open.
Yes, yes. So you don't need to reinstall everything. So we have the package for the notebooks, I'll say, for the notebooks, okay? The notebooks have all the requirement dot. We can show the requirement dot. I'll show you all the packages we install, right?
On the open thing itself, to do a dip install with their dependent.
Exactly. That's fine. I'll show you the magic. That part, I didn't sleep for weeks, guys. I'll show you what makes me no sleep is dependence is hell. That's literally word by word. That's what you'll get into. And I have a solution. That's why you're here. I'll show you right now. And then I'll show you, yes, one at a time. Sorry, I'm so sorry. 1 second. Yep. Yep. And then we can use the mic here. I think it's working now. Yeah. Yeah. It could be a mix. I think that's exactly.
So we have for post-training optimization tool, that is this one, we have integer 8 is the unit that we have. For the next tool that we will talk about, we have a mix and we can select 4 bits, 8 bits, or also select the binarization. That is not working for all architectures, just for some of those. So,
yeah.
But this is not for post. So we have 2 different tools. So the next one is the neural network compression framework, NNCF.
That's exactly that.
And that makes that part. So post-training optimization.
You're very smart people. I'm like, ooh.
You're moving faster.
Yeah. And then did I answer that question? Yeah, I didn't. Yeah. So that this is like the bigger again. People ask like, how do I install, right? This is the biggest problem I dealt with. When I started at Intel, I was like, how do I install? I spent a day to install. I was like, oh my God, right? And you don't have to do that. You don't have to spend a day because I test this every day. There's a CI behind it. So in actual reality, you only have to remember this. But in the reality we live in, you have to install all this. So we actually, all these notebooks, we resolved the dependencies already for you. So when you run the notebooks that we're showing you today, you just like basically do a dump. It's like a developer tool, right? You dump all the dependencies in this right here, and then it will install all of them for you. So if it breaks, let us know, but we pin some of that because some of them have proven to be problematic. Because it's an open source community. Guess what? Everyone does things differently, including myself, right? So I don't blame anyone, but this is the best effort in my life that I remember. So if you can make it better, please do a pull request. I'll give you a sweat. This is super hard. But this is CI behind all of this. So this is your dependencies problem. Like in short is you just pip install and then there are some of this you can use to help you answer. Yes? Device dependent, what does it mean?
Yeah, so let me show you.
It depends a little bit. I think there's like a dependence matrix that we talk about. I'll show you that because that's the most commonly asked question. What is support, right? So we end up with like a support page for the architecture. So when you compile the model, you have to make sure that it matches to that. Otherwise, it won't run because like there's no position for that, right? Yeah, I'll show you. Is it the right question? I'll show you. Depending on the hardware, right? There's a matrix somewhere. Right here, for example.
So this is supported input precision. So you are talking about models format?
Yeah. So for example, right, this plugin, we cannot take FP32 for this GPU, for example, right? Is it the question?
The layer?
One single format, it will run, yeah, exactly. It's one single format, it should run with different plugin. But the format of the model has to match at least like this. If it's 32, it will not run on here. Does it make sense? Yeah, exactly. It's cross. So if you use CPU, guarantee it will run by definition, right? Like that's the default setting. But if let's say using CPU and GPU, most likely they'll run together. So they're not like a huge deal. But we prefer this one for a good reason, performance, right? Then if you're here, you're in the la-la land, I call it, like, good luck, right? You have to know what you're doing, right? That's exactly why we have this portfolio, because depending on your need, let's say, usually I go with these two for developer because you can have access to them tonight. Your laptop most likely can handle it. Then this is the fun part, I give it to you for fun. That's a Neurostic. I'll give you a Neurostic because you asked the right question, right? That's a good question. This is the part that you should be able to play around. And then this is like even ARM, we actually partially support. So ARM, yeah, we actually do ARM. Very crazy, eh? We're doing ARM stuff too. Yeah, it works anymore. Yeah. Yeah, actually, I think I said it in the early of the meeting, not meeting this. I was the first guy did it. I don't mind saying it. Yes.
I got a question about that. Like, you have to be Intel. I mean, if I got another brand like AMD, it will fall back to a penalty.
It's x86 architecture. That's the rest of the case. I cannot say more. I don't know. I haven't tested them, but it's x86 architecture.
And regarding ARM, for example, like I imagine that if you can run on a Raspberry Pi, you can run on a cell phone.
Cell phone is coming up. It's actually one of the Intel project we're doing for some of those. So we're still working on it today.
So
follow our work. We're the crazy one, the foreign rich kind of guy. Yeah.
We can run. I was running OpenVINO in Raspberry Pi.
What is this?
Oh, sorry.
Yeah, I thought you gotta show something.
Yeah.
Yep. So the question is, yes, we will have a cell phone kind of like a demo that you can see. Because they support ARM right now, actually, we have a demo internally we can ship. Yep, questions? Oh my God, you all, wait. I gotta go this way and go this way, okay? This is round ribbon way, right? That's the easiest way. Wait, yes. And then you first, yes.
Okay, so how much was the drop in accuracy because of the quantization?
So that's the job for engineers. Usually, you have to really benchmark your work. We have a benchmark tool. That's right. Benchmark tool. So you have a validation tool. We also use that. Just basically, okay, the set away is like 80% data, we train, 20% testing. You rerun the evaluations. Every time you do that, you just rerun the model over that. That's the drop you have to measure. But in general, again, ballpark 1 to 2% I've seen worst case. So the worst case, some cases can be worse depending on the model. I cannot say it. Yeah.
Yes, but that depends on the model.
Yeah.
And sometimes if you have, for example, post-train optimization aware from quantization, you could see no great performance, but you could keep the accuracy.
Yeah.
So,
you can trade those two. But
quantization you can improve and learn your model with a good quantization with the next tool that is a neural network compression framework.
Yeah, we will talk about that. Yeah.
But you could see drop of accuracy in post-train optimization tool.
If the drop is very high, so what is the next step?
So the next step is use an NNCF. That we will talk about that. Yeah. And I want to show you next how you are keeping the accuracy with NNCF.
Yeah, we can hold the accuracy. Yes, last
one more thing, like using the quantization step, right? You need some more data to quantize the model for it, right? Because you collect statistics and do other things. So what is that?
So post-train optimization tool has you need data set just to make the validation, but NNCF, if you have the pipeline of the training, you should need new data. So you need new data to get the,
Any random data or it should have some.
could be new data.
So it can be any random data, they randomly downloaded images from internet.
I'm not sure about that question.
That's like open-ended. Can I do random things? I don't know. I will try.
I
But
don't
we
know.
should talk more because I have more questions. Okay. Next, yes.
Yeah, speaking of conservation, so we know when we convert for example, the grades from the full precision distribution to the digitized distribution, you're gonna have some scaling factor as the connection, right? You have the integer value only for the convolution,
Right.
and after the convolution multiplied by 5% scaling factor. But my question is, in the current architecture, in the hardware, what you guys did to support those kind of acquisition scaling? For example, if you run the TensorFlow or PyTorch-based Convolution pipeline, at the end you will have the scaling factor contract, which has a fiction, right? So how do you
Should get an answer for you. I think extremely detailed question.
So
Did everyone here?
So we have also in the same web page what kind of layers we are supporting for every single quantization. So, and I have one example that we want to show you next, that maybe some layers are not supported by GPU, for example, so we are not able to quantize in GPU, but we can ignore that and just quantize the rest of the network.
And in short, I think, yeah, what's behind the scene?
So it's more like a hyperposition integer, or because you know it is time sensitive for those things.
Yes.
But as you can see here, we have a lot of support for CPU and a lot of support for GPU. Almost all layers are supported. But I really wanted, we really
We
wanted
should follow
to,
up on this one.
yes,
It's a
we
lot
really
harder.
wanted to show
I know
you
what
that-
he's asking, but yeah, it's in short answer is, let me get back to you with the engineer almost. Like I actually have an engineering team. That's why we make connection, guys. I'm not the only engineer in Intel. And I would like to know your name again and then come and talk to me. I'll point you to the right person behind it. Because we have about a couple hundred people working on this, by the way, not me, hundreds, not me. Like, so there's a lot of interesting things. I would like to answer that. Yes. Sorry, I gotta go for the back because I almost missed you. Yes.
I just had a quick try to run and mention for M12 you need to recompile an X86 before you can use Residual 2. Can you bypass that requirement by using the VDA?
Using the Apple M2, I hear just some of it. Yeah.
M1.
M1. Yeah.
Says you've got to use Residual 2.
Yeah, Rosetta 2, that's right.
You've got to rebuild on the X86 to do it. Can you bypass that hardware requirement by using VDA?
I did both. Yes. So this is a good question. So again, okay, I'll just say it because I did it. It's not a supportive thing. It's for the open source fund. Okay. It's fun, right? When you build something cool. You go to GitHub, you download the source code, right? So there are ways that you can compile in ARM or in the x86, right? And then there are two different build files. So what I did is I did two different trials. One is the x86 using Rosetta 2. You just treat it like x86 the entire way. And guess what? There's something that won't work. Instruction set. The AVX 512, it doesn't support. So you have to disable those kind of instruction set to make it compile. The nice thing about that is when we compile the code, we can actually disable some of the instruction sets. So that's a trick to get it running on Rosetta 2. You're basically emulating the whole x86 environment. You have to download from the source though. Now on this right side is the ARM architecture. You can use the ARM plugin. Go for it. Try to get it compiled. You'll be one of the first again. I did it by using Docker, so I avoid the whole craziness, right? So you can either work natively with the terminal, go try and compile it, or use a Docker to emulate that Ubuntu in ARM and compile that way. That works pretty well. And then once you have that, that is a plugin architecture. So basically now OpenFino, you can, let's say you have no CPU device, right? It's kind of funny. You can compile the whole thing and CPU is not supported. It still works. You can just like point it at the VPU as a plugin and you still run the code as it, but when it runs the inference, it will point to that and go through the rest. And I think I recommend you also buy the Intel Gen 12 as a solution. It will save you a lot of headaches. And it is for fun, right? Okay, back to you. Is it okay? Good answer, hopefully? I try everything. It's not easy. Yes.
So is there any graph about optimization versus power consumption?
Yes, we have the whole benchmark. I'll show you the benchmark a little bit how it works. So if you go to documentations, there should be performance numbers somewhere. Well, that's the benchmark tool, but we have a benchmark somewhere. Where is it?
Let me find it. We can come back to the.
Yeah. Well, I'll show you. We'll show you the whole list of, let's say, power. Basically, we did two math. It's actually a very useful math. First math is, well, FPS, you know, like how fast, right? But more important is like gigaflop per second, like the actual, you know, crunching. And after that, we evaluate against dollar per watt or something. I forgot. It's like what the number. It's like you spend that much money for power or performance. So we calculate based on the wattage, right? Like let's say this is 20 watt, right? And I crunch this much data. So we have done that computation for you. So you don't have to do it. We have a person called Michael. Hi, Michael, if he's virtually there. So he's trying to say nice thing to you right now. He did all the benchmarking at Intel. So what he do is like we basically replicate the setup in a machine. We basically have a test configuration. He keep crunching the number hundreds of times. And you don't have to do it. Right. And we have a solution called DevCloud. Oh my God, I keep doing this. Yeah, so you see all this? Right, so on the right side, left side. Yeah. So you can see different model. For example, let's point at YOLO 3-4, right? Everyone talk about YOLO every day. Yeah, you only live once, but now it's no longer you only live once, you only look once, I don't know. So YOLO, so you can see like how well it performs. I'll go around here to show. So for example, if you look at this, scroll down a little bit, you can see like, okay, efficiency, right? So we actually help you to calculate this because like right now, if I were trying to make a purchase decision, like it should have Gen 12 here coming up here, right here, City Gen 12, right? You see like this is like killing it, kind of what we call it killing it, like way up high, right? And then you scroll down, right? And then efficiency is not that high, maybe. So when you want to do mobile, you want to do this one. So you really want to make this kind of trade. You want performance more or you want more efficiency more, right? So that's actually the hidden secret, right? When you make purchase decision, the last thing you want is you buy it, test it, and doesn't work. Oh my God, I don't want to step on her gears. She would not be happy, trust me on this one. Don't touch this video. But that actually helps you to get through the efficiency kind of problem, right? Like, is it better or not? Okay, does it answer your question? Yes, hi. Again, there's a train behind me, sorry. You want to come up and then talk a little bit? Yeah, the mic, I think it works. You don't want? Yeah. It's fine. Yeah. Yeah. Yes. Yes. Yes, then you should talk to her. You know what she did? Yes. Yes. So let me repeat the question for you, is that okay? So I don't know what you do exactly, but you want to deploy something in the forest or somewhere remote that you want to have high efficiency. You don't want to carry a big car battery to power your computers, right? And then how do I make these kind of decision choices when it comes to what we're doing? Well, Paula has a lot of experience. Why? You may not be here in the early time. She deployed system on the field for coffee, for farmers, right? You work with a lot of farmers in the past. How do you make purchase decision?
So the important thing here is a balance in between low cost and efficiency. So maybe you could keep something imperfect, I mean, no high precision stuff, but something that is easy to implement in a Raspberry Pi or just a single board that you can just run the model there. So you don't need to use a BPU itself. If you use a BPU, you can keep a better performance, but the low cost maybe is out of the box with that. So the point is that you need to think about that the optimization is important, but also depending what kind of things you need to see. We need to see optimization, better performance in real-time systems. So for example, in agriculture, I was working in different kind of things. So in the real-time system, the sorting copy machine that I made, I was using just 8-bit processor. And I make my machine learning stuff. In that moment, I didn't know about OpenVINO, so OpenVINO didn't exist at that time. But it's a balance in between that. So here you could have and you could see, depending on the images that you are getting, what kind of models you can run and what kind of hardware. Depending on that, you can make decision what kind of extra acceleration you need, or if it is enough.
So from my experience, I built a company that's augmented reality headsets, right? If I have, let's say, very limited engineering resource, I always like use a laptop for example, right? Optimization is hard. Trying to get something running on small devices is worst, right? So I will always like use a laptop to get prototype. And once you understand your requirement better, when you come to purchase decision, come talk to us. We have a whole team just like give you a portfolio of hardware, even the future one, depending on your launch time, so we can optimize the cost for you. Because a lot of our partner, actually, Intel is like a chip company by definition. We make chips. But we also work with a partner like AD-Link I talked about. They build a box for you. They're the OEM that actually what they do is they take our silicon, they package the way that the user needs. So their industrial use case that you can drop it from a helicopter and still survive. It's like, damn, right? Look at this, that's robust. And I can even drop my computer this far without denting it, right? So they have different requirements based on what you need. For your use case, if I would recommend start with the laptop processor like the Titlex, because it's extremely high efficiency. It may be a bit expensive, right, in the beginning, but you're buying a laptop to try. But then you try to look at maybe like you go down the list, maybe like, okay, maybe I can get around it with Atom, right? Different type of processor. But don't slow down your work pre-optimize too early, guys. Like that's the number one mistake. Because I want to optimize everything, but get customer buying it first, right? Once you get deployment, it's a completely different story. And then that's where we can have a lot. We have a lot of people who tried it. Yes.
So what's working on the Kinetics trail path, these little vision chips that they put in forests, I think it was a partnership.
CPU, yeah, that's a company, OpenCV.
Luxonics.
The Lasonias, is it Lasonias?
Luxonics, that they made a camera, a smart camera with the inside.
So they basically.
Like a Facebook side.
Yes.
Yeah, I think Lasonias, that's the company. Well, I know the CEO. Yeah, we're friends in short. But the way they do it is they took the VPU right there. If you're interested, please grab one. Stephanie, give her one of the VPUs to try. That's the exact one. Again, when you ask good questions, it's all yours. Like swag is for you. Okay. No. So take one and then try it. So that one is basically what's built into those cameras today. So they have this kind of embedded device system, right? So in short, there's a lot of options. What questions? I'm sorry, I have to keep moving on.
I want to add something extra.
Right.
So that is important that you know that. So for example, OpenVINO is running in ARM, but the performance is much better in Intel hardware. So that is the point. If you are looking for some board that is maybe board Intel inside, is much better. And also if you have the hardware acceleration, it's much better.
Right. So we are about to take a break. Any last questions? Okay, two last one, then we will take a small break because I need about 5 minutes. Yes, please. Hi.
Hi, so I have two questions. First, I'm not sure what you mean by optimization, but I'm just guessing.
Yes.
Moving some of the coordination layers.
That's one. Yes, in the early slides. Yes. Yes, we've done that too.
I was involved in project for mobile.
Yes.
We noticed that after optimization, we mainly regain some of the performance that were lost.
Yes.
So, do you consider such retraining after optimization?
And then we have the it's coming up in the next session. So it's a good prep for, this is not the magic bullet only. We have, let's say, what we try to propose today, the plot is don't miss out. That's step one. Try before you invest your time more. Like see if that will solve your problem. If not, we have another tool called NNCF. Memorize it. I know it's a lot to memorize it, but that one is where we go back to the basic form. The moment you start training, let's think about optimization, right? So my go-to story again, try model optimizer, brain free, You just make it work, get some acceleration, you see immediately. Step 2, pod, right? Trying to quantize your model, make sure you can, trying to grab all the benefit you can get by doing like what you just talked about, some of that pruning, some of that will give you something. Then if that's not enough, welcome to the last game. If that's still not enough, we have brute force, we have still more. Then I'm done. If you cannot get it enough, we have to keep talking about your hardware. Oh no, we have new hardware coming up. I didn't talk about it. Yeah, we have Xeon processor. Pretty good. Yes.
And one more question. Is it just for contest or other applications of computer vision that have to be run on GPU? Let's say have an algorithm that does stereo vision that requires you to still be applied.
I don't see the problem. Like we even support NLP. We have like real-time series. Like it's like almost like less of that issue. Like 6 years ago, maybe that was okay. We should talk and show you more of that. I think the bit of the introduction that you missed, then we'll get back to you. All right, we need a break. We need to go to the bathroom. One last question, and then we have to go. Yeah.
So did you guys benchmark against NVIDIA's GPUs?
Good question. There's a couple of slides that you can see from how we benchmarking with Jackson and all that. I think if you sign an NDA with our partner, you most likely have access to those. Yeah. Publicly, we don't like. I think our value proposition is like performance gain here is there, but most important is the portfolio, right? If you're an engineer, you deploy something enough, you know that purchase decision is not just because that 2x sometimes. It's the overall package, right? You have to ensure that this is the consideration. Everyone like always feel about, oh, 130 FPS for YOLO. It's like, for what? I need 30 FPS to hit the mark so I can track the people, right? So that's the portfolio is good for you when it comes to launching your applications on the edge. Choose carefully because every single thing here comes at a cost. And money, it's not easy to find when you're doing business. I did my business again. No, okay, no more questions. I'm sorry. Is it last one? Last one, everyone agree?
The question was about transformers. I don't see any benchmarks for transformers.
It's work in progress. Work in progress. You asked the right question. We have an NLP example we can show you too. That may help a little bit of like direction. We can get numbers. Yeah. All right. Break time. Please come back for the really interesting second half. And if you come back, these swag actually at the very end, very likely will give up most of them. That's why we put it out right there. The pyramid I built right there is the neurostic again. Water bottle is for the first because it's so freaking hot here. And speaker is when you have a party tonight. And then you have our charger just in case your phone runs out of battery again.
Oh, no, this is
Really? Oh, yeah, that's USB, right? Yeah, so it will charge your phone most likely. And t-shirt is, anyone has a question, most likely you'll get a t-shirt today. I actually programmed that t-shirt. See that? It's my program. My programming language style, see? Python. If you want to get speed up, it runs if you write the rest of the function itself, okay?
Now we'll have the first question. You can figure out the regular opening of that.
Oh, they shrink as well. Make sure you get slightly larger. So I get the medium and turn it to small. So just in case. Oh, you don't understand it? That's okay because it's not like, so basically it's a message. It's not, okay, I am engineer, but I'm doing marketing. So come back, okay? I want to give out all this before I go today. And invite your friends, please, because more people show up here, the better everything will be. All right, it's okay?
10 minutes. No.
10 minutes, okay.
15 past 3.
Yeah, 10 minutes, like I'll stop for a little bit, but you don't have to go, you can still sit down, you don't have to like leave the room. I'm not cleaning the room, but you can like go pee wherever. Yeah. Yeah. All right. We will pause the audio there too. And then for the virtual audience. Yeah. I think we will walk around too much. Yeah, here's something.
It's recording again.
Oh, we're recording again. Hi, welcome. I gotta be nicer. Oh my God, need my job. All right, let's get going. So the NSCF is the Neural Network Compression Framework. This is the part that I gotta bring my expert again, Paula. No, just kidding. Right. we'll have a lot of expertise behind it that will talk about this. This demo is quite intriguing because when I read this, I thought this is impossible. And once I see the tool, I was like, not bad. But once I finish reading it, it's pretty repeatable. Repeatable means like you can try this out. We have like 2 kits around it, you can try it. To start, I'll say I'll conceptually talk about this, why you need it. Some people ask me like, why you do post-training only? Like, why don't we start optimizing your network since day one when it started, right? Of course, Intel thought about it too, in many ways. So some of the engineer behind the work, they put together the toolkits. Is it easy to use? No. But is it usable? Yes. So that's why today we're going to give you the easier to use version that we put together for the audience. So this is brand new. You can look at the GitHub commit. It was done, what, yesterday night?
Yes.
That's a reality I'm living with. Like the setup, we barely sleep. So tell your friends, guys, like that's what I'm asking. So what we put together were all this question people ask, like, how can I get the network to behave better since day one? By putting this mixed precision quantization, people ask, putting in the pruning early, and making sure that you quantize, like emphasizing your network so that they're quantizable, right? And I don't know how to do this perfectly. Again, I use tool. I'm not the engineer inventing this from scratch. So this tool will help you at least that when you're training your network, making sure that your post-training optimization can be most effective. And what that means to you as a user, you can like a graph, better optimization steps that you can try yourself. So this notebook, I'll show you why this is important as we showed this at our conference last year as well. We've been closely working with our healthcare companies. If you don't know, actually, Intel works with a lot of healthcare companies. I'll name a few. GE, I talked about Samsung, Philips. So I hope you don't get sick, but when you get sick, I was like, oh, I know Intel. Yeah, I know. Yeah, so that's for me. Don't get sick, guys. Now, this demo for you, you will learn the entire pipeline again. It's a very detailed and complex things. I know Paula is tired too, you can tell. I'll help her a little bit to show this. And what you take home with is how much better can we get still? I'm not done. Is that crazy? Everyone's like, oh, this is how slow CPU is. Then I was like, oh, better, more better. And I have brute forces at the end. So let's get ready. All right. Your computer crashed? Oh, don't worry. Sounds about right.
So
Just kidding. No, she's starting. Like, no.
I will restart.
She's like starting the computer. Yep. But as you're putting up the computer, is it you?
No.
Right. You're putting up? Yeah. So as you're putting up, I will maybe go back to, I'll go to the next slide quickly and then explain how this is going to be rolled out. Anyone can go on this on the cell phone for me? I'll explain the code quickly. Cell phone guys, take it. I'm sorry. She have to put it. I have to do it. If it doesn't work. All right, let me try it. Yep. 1 second. Yep. So that's a GitHub. I cannot emphasize it more, saying that like why this is such an important thing. So in here you see like the exercise, right? We want to basically run the NNCF one. Where is it? NNCF. Sorry, 1 second. Sorry. Okay, so we're gonna run a couple of tasks today. So that's just like we have something called a Depthwise. People see it. But the data set actually used extensively for oopsie, come back. Right, extensive for segmentation problem. And again, sorry, I should scan this one. This problem is basically you have a set of this kind of MRI, right? Like images that coming out from a machine. And what this will do is like, you see this, see that? The red part? You know what that is, right? Anyone? Anyone with medical background? You know? No, I don't have medical background. So
Separable.
This is the part that you don't want to get a stone in. I talked about last time. Kinning. This is the one of the worst thing you can get in life. So what this MRI is doing is actually it's taking the cross section of a human body. Okay, it's kind of gross, but this is how it is, right? This is my body, slices. And each of these slices are represented in these animations. And what this algorithm did is the red part is the segmented part from your body. Say this is a kidney. Why is it important? Well, I think I talked to my brother, by the way, he got his medical degree. Yeah, I'm not joking. You can look me up. My brother is from Harvard. I'm not even kidding. I joke a lot, but this is not a joke. He actually did medical imaging as a radiologist. I'm not even kidding there. In oncology, you don't want to get cancer. But they spend a lot of time on reconstruction, right? You want to see like your body, or sometimes you want to do diagnosis, you want to do like surgery. All this comes down to a person that never seen your body. It's like, look at the diagrams, like, that doesn't look good. And then they kind of figure out, right? So the visualization actually is a huge deal for radiologists and clinicians to make sure that they do scan properly and then getting this out. So I can only, yeah, are you ready?
What is the puzzle of
The CVPR, I'll do it for you.
capital?
Log into Yong first. This is Yong. Yeah. Then I'll log in for you. I want to share the screen and get through that. All right, that's your password.
Just you.
No password?
Use your, yeah.
Let's just do it. Password?
Use your account.
Okay. 1 second.
So let me explain you something here.
Well, okay.
So I want to explain you something related with the differences in between POT and NNCF. So because maybe we can have like maybe some confusions in between. So both are for quantization. So POT is that you already have the pre-training model or the of the model that you want to improve, to quantize. And you have also a data set. So this is post-training optimization tool, POT. NNCF could work when you have the pipeline of the training. And this is working for TensorFlow and PyTorch. Why is important? Because we are able to retrain the model. Because we need to use just a single and magical command line just to make the quantization during the training. So we have different algorithms that we can run there. Quantization aware training. And also we can make like a binarization. We can make filter pruning. And there you can find also you can find like a preset. The preset is important. You can see how can the performance change with the preset. What is the meaning of preset? So when you have the quantization, you are able to create like a synchronized quantization for weights and activations, or asynchronized. So we have two options. One is performance for preset, and another is mixed. So performance, we are making synchronized quantization for both weights and activation, and mixed, we are making mixed. So we are using synchronizing and asynchronized. Synchronized for weights and asynchronized for activations. So you can see somehow the performance could change. By default, we have these things are also common in between the two tools. We have POT and NCF. POT has two algorithms, default quantization and accuracy aware quantization. And NCF has these 5 algorithms that I mentioned, but the preset is exactly the same. So for quantization, we have fake quantization and also pruning. Okay.
Yep,
So,
sure. Can I?
okay.
My God, my demo is so hard. Yep, not me. Yes, me. I can say anything. Turn it off.
Yes.
All right. So the next thing you'll be seeing is the code. So this will be the detailed one. Again, you all ram up the idea already. So this is the actual share screen.
Okay.
Share screen. We hijacking this. All right, close the left side. And let the show begins. Questions? You want to sit over here? So,
Yeah, well,
it's okay.
Yeah.
Yeah.
So this second presentation method that you say during training, so it doesn't use the model optimization that you mentioned before, right?
The what?
The model optimization. So
It's still part of the pipeline.
Yes, so the pipeline was model optimization and then the quantitation.
No.
So if you want to do it during the training.
No.
The short way, I think, let me use my hands actually helps because sometimes just if you can remember what I said here, there's no way to remember the code anyways. Dataset, okay, on the right side. Training, again, let me see the camera. Dataset on the right side, right? You start doing training, right? This training, oftentimes you do it without Intel, right? You just like, just train. Now you use the toolkit that we provide with the NNCF. Now you did your training. The training, the only difference now is you don't train it like blindly. You train it with, these kind of tips and tricks here and there inside the code. Then once you have the model out, it's still, maybe we'll use PyTorch to train, I think, or TensorFlow. Now your model, now you go through the model optimizer. Just like you prep the model better for my optimizer, right? Then after that, you go this way, post-training optimization again. Then you keep going, then you get this, then eventually I disappear in this camera. But it's not a very long pipeline if you think about this. And again, if I can explain it by hand, there's no way, right? I don't remember anything more than 6 items, guys. Don't you have that problem? Yeah, so we all agree, right? Okay.
Is there some differences in performance between NNCF and
Yes, right. Okay. The idealistic case, again, I have to sometimes use that word. You do NNCF and plot together, you get the best of everything because you really prep your model perfectly, right? Not perfect, it's like as much as you can. If you're doing just with the plot, let's say, well, I don't know why they use plot. So we were to, that part will give you only as much I can do, right? You cannot have prep the model the way that you can optimize for, right? So like, for example, we talk about the mixed position, right? Some of the layer, you have to readjust them a little bit. You want to get the best of the best, do both.
Yeah.
If you ran out of time, like what I just said, you have a boss tell you to give a demo tomorrow, shove in the pot and get it out, right? And always do what is good enough. Sorry, that's a joke again, I'm sorry. Oh, my job is hard, my kidney hurts. All right, let's go. So shall we? All right, let's go through the code. This is the part that you need a lot of patience. Okay? Are you okay, Stephanie?
So we have this, just let me show you something here. I'm looking for the GitHub repository. We have a GitHub repository for NNCF. So, and I invite you to see the repository. We have a good documentation here. So this is the compression algorithms that I'm talking about. So we have supported for those in PyTorch, fully supported. Some of those are supporting in TensorFlow. So for that reason, if you have the pipeline training, you are able in TensorFlow, in PyTorch, you are able to do that. So let me show you like a general view of how this is working in general. So in general, we have here, and this is an example with a ResNet 50. So we have here the pipeline to open the NNCF library and also the torch function that the NCF library has. So the magic here, so we are working in different things here. So just saving, open the data sets in the Python, in the PyTorch format. So the magic of NNCF is coming in this specific command line.
Bigger.
Bigger.
No one can see it. Bigger. Bigger. Anyone can see now? Yep.
Okay.
All right. Sorry about that. I can't see anything too, so that's good. Let's keep
Okay.
going.
So, and with this command line, you are able to load your model, but you need to remember the pipeline. You need to have the proper installation of PyTorch and run the proper model. So I want to jump to the demo that we have today. So this demo is a beautiful demo that the notebook that Helena, one of the engineers that we have in our team, she made. And this is a series of demos of notebooks. So you can visit the OpenVINO repository. In this 110, you can find 4 examples. And you can run here different kind of things. You need to, maybe you can train the model itself. You can, if you have the access to the data, you can train the model in PyTorch. You can prepare the data because this is not a single data. This is a CT scan data. But you need to have some time to have this training. So for now, just to simplify the tutorial, because we don't have a lot of time, we have also the pre-trained model in the notebook. So you don't need to train the model by yourselves. And here we have the POT. This is the notebook for POT, and this is the notebook for NNCF. So, and the differences in accuracy between two are not huge, but it is great for the educational purposes. So you can see the structure in the two tools that we have, POT and NNCF. This NNCF notebook is working with post-training quantization. So we have quantization aware training, and we have also post-training quantization. So in this case, we are, okay, let me show you here. So, okay, so if you have Windows 11, I don't know if somebody here has Windows 11. So we have some issues with Windows 11, so and you need to find the proper CPP compiler. So this is if you have Windows, so you need to find the proper compiler.
Any Windows developer? Anyone from Microsoft here? Okay. Yeah.
Okay.
Who doesn't have a problem with Windows development? I want to ask.
Okay. This new machine.
Yes, new machine, right? So sorry about that, but if you're using Windows 10, it's fully supported, right?
Yeah. So, okay. So here also something that I want to mention. We are using Monai. So I don't know if you know. Do you know Monai? So Monai is a framework. It's a medical framework that you are able to get their data sets for different things. It's an amazing framework. So you are able to create augmentations of data sets. So you are able to download information. So it's a great framework if you are working in the medical sector. Monai here. Monai.
You actually use it? Who used it? Who's the user?
Who is working in medical sector?
Anyone?
Here. Anyone is working in medical sector? Okay. So, okay, so we can continue.
That's why you earn a lot of money, because you're very hard to find. If you know medical and AI is a very hot field. Right.
So in this notebook, we are downloading the data set, and we are using that for quantization. And we have the data set here. So we have also the PyTorch model that we already trained with the rest of the notebooks that I showed you. So, but in this case, just we are giving you the link to download the model. And something that we made with these PyTorch models, as I mentioned, so we made we convert to the OpenVINO format, the intermediate representation through Onyx. So because we don't have the direct connection with the PyTorch, OpenVINO with PyTorch. So something that you can see here is also the model optimizer argument, because we are also working with the model optimizer that is at the end of the pipeline. So the first thing, download the data. If you don't have the data in the cache, so you are able to download the data. We are using in this case just one case. So we have one patient. So this is the new data that the system has. It's just 69 or 68 images in this CT scan. We are using that to run the quantization. So the configuration, so this is the configuration of the data set, and this is the common configuration for a PyTorch data set, so we don't have anything different here. So And that is really important because in the CT scans, a lot of information, so we are looking for kidneys, no stones or something, no, it just create a semantic segmentation of kidneys. That is the thing that we need to do. What happened in a lot of frames that we don't have kidneys. So we need to avoid those images for the data that we want to try. So in this case, we have this, this filter here, just to avoid images with less than 5,000 pixels in the mask. So we have the proper data set, so we are making the proper data set here. And also, we are using F1 score from also from PyTorch.
What's F1 score?
F1.
What is F1 score?
Is is there relation between precision and recall?
Precision recall hybrid.
Yes.
Yeah, give him t-shirt. That's right. That's right.
So the quantization, so in this case, we have the proper FP32 model for comparison. And this is where the magic starts in this configuration. So we have here the size, the input info, that we have one by size and one channel and 512 by 512. And the target device is CPU. In this case, the algorithm that we want to use is quantization. So we want to use just quantization. And the preset that I told you about that is performance. This is the default configuration of NNCF, quantization plus performance in preset. And one of the tasks that I invite you to check for this notebook is just change the preset to mix it. That remember that we have synchronizing quantization for performance in both weights and activations. But mixed is synchronized and asynchronized. So what happened with this, and this, I love this example because it shows us how the quantization is working depending on the device. We need to ignore this layer because this layer is not supported in GPU. If we want to change the device, to GPU, we could see an error in the notebook. But you are able to change the device to GPU because we are ignoring that. This is also the roadmap. They are working on that.
So that actually answers some of the use. Like, is it always working? No. No, you have to try it. Make sure you understand like some of that. And if you don't understand it, we have a forum that you can ask those questions, because when you start working with many models, there's some layer that's just, you have to look up that support table again. You have to work around those a little bit if you want to have different architectures.
So essentially, you interface handle, like inject knowledge about the platform.
Yeah.
This way, I don't know when it right, so
In this kind of tools, yes.
Yeah.
In this kind of tools, yes.
If you optimize for GPU, guarantee work on CPU though.
Yeah.
So if you go a little bit further ahead of the curve, then oftentimes backward compatible. That's my usually game to do.
And that also is important to know that not all models, not all layers are supported for GPU, but all layers are supported for CPU.
Right.
But just a few are not supported for GPU. Yeah. And those ones are in the roadmap in our engineering team.
Couple questions? Yes. Yes.
Do you support the customer res if the operation does not supported by this device? Could you automatically reload this operation to the CPU?
Oh,
we have
a small one. Yeah, we actually have that.
I know the answer. You can implement it yourself, the conversion part.
Yeah,
No.
but do you offer such an automatic way to do it in your device? Not by the
I know what you mean, like fallback, right? Yeah. So the TensorFlow extension that we did, like the TensorFlow integration, we have some of that work in place, yes. But not every one of them. Like we have some of that, yes. The short answer, yes. But I still recommend do that work, and then worry-free. If you notice a bomb you drop that will explode later, fix it, right? That's why this tutorial is for you guys to see the entire pipeline and process. It's not that bad. If you do it once, spend a week there, then you can be a teacher almost. Almost, okay? Yes.
I'm trying to understand this flow chart. So you got pre-trained or trained model. Then you have your model optimization. Then we talk about the post
Yes.
training. Where
Yes. 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 Yeah.
Where this NCF?
Where's NCF? Which?
NCF sits at the beginning of.
So an NCF is making during the training of your in your pipeline. If you are training in PyTorch, if you are training in TensorFlow, is doing there. It's inside of the framework.
Oh, it's inside the.
Yes, inside of the framework. Because it's making the retraining again.
Yeah.
So that is the way that NCF is working. So for that reason, that is a big difference in between POT and NCF, because you need to know the pipeline of the training in NCF.
So the person here, if I have to see out inside that training process, I still need to do the model optimization.
Yes. Yes. Yeah, I actually mentioned that to that just there. I always think about like left to right, right? And NCF is like when you have data and training, get it all ready.
Right, and then after that, like the pod and all that is on the left side, right? In the middle is where you get your model first time, then the model optimizer is next to it. You wanna, that's your, I always think about model optimizer is the first step, just to push a little bit, see how far you can get. Because I go from FP32 to FP16, just doing that little bit of that, you don't lose a lot of precision at all, and then you still get really like maybe some speed up, and you have a smaller model size immediately, right? All right.
We are giving.
One last question. Yeah. I'm gonna repeat for the audience too. Yes. Yeah.
So, do you guys have an open optimized version of for the famous architecture, let's say Mascot and pre-trained on Convolution?
I have a lot of pre-trained model. It's coming up. So the question is, do we have a lot of pre-trained model? We have a lot. And we support, I mean, that's the word, like 300s. And then we also have supported, let's say, other companies, let's say Paddle, right? Let's say a couple hundred there. Most likely, if you're a developer, you can kick off some sort of like hackathon with the pre-trained model we have. Like you don't need to start from scratch, very likely. But if you're doing business, you have to get serious then, as a, depending on your use case. Huh? No, it's there. I'll show you. Yeah, we have hundreds. And that's why all this demo, we basically showing you all the demo. It's all there. Right, again, going through this is hard, I know. Memorize it if you can. If not, it's okay. It's all document.
Go ahead.
Just a question, NCF is running on the GPU?
The training.
Yes, the training is you can run in both, but for
Whatever
sure,
you like.
yes.
Yeah.
Yes.
Yeah,
Yes.
depending on the number of a processor you have, right? Let's say if it's Xeon server, you can do however setup you like. We're not limited.
So, okay, I will come back.
Yeah.
So remember the magic command line that I showed you here in the documentation of an NCF. So we have this command line here, and here is where the magic is happening. In that case, we are making the compression using the pipeline of PyTorch. So just for educational purposes, we have here the compressive model, so you can compare the model here with another app if you want, compare with the native model that you already have and see the differences in between. So I invite you to do that. So, okay, we can continue. I don't want to go deep in that. So the next part is, okay, we need to convert, and you know this part of the history, we need to convert PyTorch to Onyx and then Onyx to OpenVINO format. And this is mandatory, we need to do that because we have just the PyTorch model. So I will run this notebook. Okay, let's see. I think I need to start with that.
It's further on.
Okay, so.
Show the exciting part, the very bottom. Show the results. So you can go back to the top. Yeah. Because like it will run, otherwise you cannot see it.
Say it?
Yeah, this one here. Yeah.
Do you have a question?
What is the need to create an alternative representation for the next? What are the differences in the values of IR?
Because it's an agnostic tool.
Repeat the question
Okay.
for the people.
So you mentioned what is the motivation to create open binary format?
Yes.
Okay, so this is agnostic tool. This is an agnostic tool that we can create, we can put different models, write once, and deploy everywhere. That is the magic of the intermediate representation. So we have this XML and binary file, because with that model, with that format, we are able to deploy in every single hardware.
Behind is still Anchor.
Independently of, if you, I mean, the message is write once, deploy everywhere.
One next, and they annotate one next in different ways on the platform. So essentially, you're doing, I mean, it's a choice that is it doing a design choice just to have a different format?
Yes, but you know, is this so you create the model, but you compile the model in different hardware. That is the difference.
So the IR is compiled. The IR is not compiled.
Yes. We need to compile in different in different device target.
So it is annotated in a way and compiled.
Yes. Okay. So let's see. Okay, this is still running. So
Sorry, can you explain that part again? I can understand like why the choice of open view and not on next.
So maybe I'll help you a little bit. That's actually like been one of the long debate. I also talked to a couple of engineers, right? Onyx is open. Like the question is like, why not just Onyx and forget it? One format and then not to think about conversion, just like one thing, right? So when you have a lot of customers, everyone's doing the thing, and then you have your hardware and you have the validations, right? We first, in short answer is we do support Onyx, right? We're not like isolating it completely. So you can actually put in the Onyx directly into our inference engine, it'll run. That's a secret weapon that we actually don't talk about a lot, right? It actually will run. And we still go through the optimization step and all that behind the scene for you. So you can just like, remember the 6 line of code? Yes, plug in the Onyx model, it'll run. But optimally, right? So when you start to deal with a lot of customer with different format and all that, that's why we created this intermediate representation so that I wouldn't say it's a control problem, but like sometimes you need to know what you're dealing with, right? So we can now guarantee this will work seamlessly with our hardware, right? All this like extra work that we put in here. And we can always, you can re-export it to Onyx however you like, right? Separate problem. But in short, when you have a company, you have all this hardware, when you create a format, it's just a lot easier for handling a lot of like variants, right? Last thing you want is like you come to Intel, it doesn't run. And then it's not my problem too, because it's not my format. So I cannot support all the format, right? But in short, we're supporting Onyx up to various level. And we also the executable provider, I think execution provider, not executable, execution provider for Onyx runtime. So if you're using Onyx runtime, anyone ever, we also helping accelerating network. So you can think about, yeah, so we're very nice. I don't see our company does that, right? So we're doing that as well. Make sense? Yep. So if you're Onyx user, go plug it in. But if you want to be, you know, max out, go with the step we're teaching today. That's the reason. Okay. All good? Yep. There's no right answer. So maybe 20 years later, it's only Onyx, who knows, right?
You mean maybe there's some problem with the Unix format?
Onyx, because like we can only support up to certain, right? So like we cannot guarantee all the backward compatibility, right? And we cannot like, there's always a reason there's certain format that exists, right? It just, and it's not hard once you've done it, you don't have to deal with it a lot, right?
The problem with generic and specific.
Yeah, and then it's like you want to use Photoshop, like you can use JPEG, you can use TIFF, or however format, right? Fit to your needs, PNG, right? It's still images, you asked me, but like JPEG may have more artifacts, right? Compression artifact, impact, like. So, all right,
So-
what are we looking at?
You have a question?
Oh, when you use, I don't know if you answered this before, when you use Onyx execution provider, you get to also use say other bells and whistles at 16 or hot training.
It's pretty close, yeah. You but I would say it support in some way. You can almost like, yeah, it works in some way. Some caveat. I don't want to spend all the time explaining all the delta right now, but when you start executing it, you start to notice some difference, but it does provide acceleration. So it does accelerate the work. If you use the Onyx runtime with the OpenVINO execution provider, we will get speed up as well. But I still, come on guys, sometimes, you know, if this works, it's 6 lines of code, come on, right? We can play 6 lines of code, right? No, it's a lot more, but I think it's worth learning if you're in the field. This will not go away anytime soon. We're supporting it fully with hundreds of engineers. So also good news.
Okay, so let me continue with this. I think that one of the metrics that you want to see here is, okay, what is the size of the model? What is the space that I'm using with the model after using NNCF? And you can see here the difference. So we have almost 8 megabytes in the quantized model is almost 2 megabytes. So we are talking about is 4 times less. So, and this is great. So also for the metrics that I remember that some of you made the question.
What's that one?
So, no, what is the comparison in between the performance, I mean the accuracy? And you can see that the accuracy could be a little bit less, but this is, I mean, if I put these two digits, it's exactly the same.
Yep.
And this is great. So you are getting a great quantization model that you don't see the drop of accuracy, and this is great. This result is great for quantization. One of the things that also NNCF has is like is a friendly tool. So you don't need to be a expert in quantization. So you can run this with no expertise because we have default parameters. So, and also the performance. So in comparison, so we have the native model is 50 frames per second. And the quantized model is almost the double, it's 2 times. So, and that result is really, really good for quantization. If you know that you are experts. So you know about these kind of results. And at the end you can, okay, sorry, you want to take a picture? I saw your intention. So, and also you can see here the results. So you can see how we are detecting the Kinetics. And this is great. And the show inference, I mean, show the inference here.
This is live, by the way. It's not a GIF.
This is a live.
So now if you're, I don't know, I think about use case, like technicians, right? Now you don't have to worry about performance. You can like have a slider. Now you can see different piece of it. You can make changes, tuning some of that, how the parameter inference works. That's a lot better than like every time I click a button, 2 days later. Well, that's happened to my hospital before. 2 days later, I'd be pretty much dead. So this is like a live kind of things that the clinicians can use for like making sort of, well, however they want to do a diagnosis or inspections or wherever that is. Yeah, when I see it like moving, I was like, it's a gift. No, it's real. So it's live. Okay.
Okay, so we can continue. So you have questions about NNCF? So I invite you to visit the repository that the OpenVINO ecosystem has. It's NNCF in the OpenVINO toolkit organization. So you can see documentation. They have also a scientific paper. So you can read that if you need to know more about that. We have different kind of algorithms supported that depend on the architecture of the model. But you can read more about that. So because we need to move forward.
Yep. Let's talk about brute force because now we optimize the heck out of the software. Let's talk about hardware hacking. Are you ready?
So if and just to finalize something, if you need more optimization, just we will talk about OTE after the supported devices.
So Thank you again. Again, the reason you're here is not to resource code only, tricks. We're gonna give you tricks that will save you a lot of time. What's Intel again? What do we build? Hardware. If I don't talk about hardware, it's almost like I go to McDonald's not getting a burger. All right, so let's talk about hardware a little bit. Is what can we do, let's say right now, simply to boost your performance without much of the code changing? And how this will be relevant to you on edge devices? That's an important topic because like where people keep asking like, well, what device should I choose? Sometimes maybe you don't want to choose. Make it automatic, right? Automate that process. Because like if you're an engineer, you know that we never want to do something twice. If it happens twice, try to make a function call, maybe. If it happens enough time, a test script. And then if it's something that actually very scalable, you want to make sure that you have a platform behind it. So this line of code, I'll put it back again. Remember this first 6 line of code? Let's start with device name, what it can do beyond just CPU, GPU. We have more, right? So some of the early people come, we show you how to run inference on CPU. That was great. We have a GPU. So if you have the iGPU today, I can talk about this now actually. The discrete graphics card can also run this. Yeah, you guys heard Intel get the graphics card discrete. It's coming up. So OpenFino will support that too, officially. And you have this mirror X, which is a neural stick. All of you stay till the end, you'll get one. If you want to get 2, you have to give me a proposal. We have heterogeneous. Basically, you can have like mixed. People ask like, can I offload? Yeah, we did. Yeah. We have multi, basically in parallel to run them side by side, right? You can do that. Are we done yet? Like, aren't you happy? It's like a buffet here for hardware. We can do the last one. Oh, you want to take a picture? Yeah. Yep, don't worry. I'll do it for you. All right. Are you ready for the last one? Auto. I talked about a little bit, but I'll go in depth of why this is such a good news to some of the developer. Is it's automatic. If you're America, you know you drive a car, you just put, you don't have gears. Oh, you have gear, put D. It's like break it, put on the gas. Anyone drive a manual here? Anyone drive a manual car, right? Like, you know, right? In America, you don't have it. But I drive a manual car, by the way. I have a BMW M2. Yeah. You know, but I love manual and auto in the same way, depending on your use cases. Because if you're in a traffic jam, the last thing you want in your life is a manual car, stick shift with a heavy clutch. If you don't know what I'm talking about, don't worry, look it up. So what we're doing is, auto is for the convenience for developer for deployments. What does it mean is now, let's think about a couple use cases because we handle some of the hard work. I call it brute force, right? You don't want to be doing any work. You want to look good in front of your boss and your customers. Choose some of the plugin that we provided. Now, scenario number 1. All of you have done this once in your life. If you haven't done it, you haven't done parallel programming, you haven't done this. If statement. Is it how you switch device today? Or you just have a different complete binary, just like CUDA or whatever, right? Or OpenCL, right? All the big names, right? This is like an ongoing pain when you're deploying with customers that, as I said, right, today I'm going to give you the lesson we learned as Intel. When 1,000 people ask you this question, you want to come up with a better solution, right? Everyone, if statement, if that. So this is for future-proofing our applications. When you build an application with OpenFino, what you end up with, let's say, using auto plugin is, you don't have to redeploy your system. Your source code can live in the system. You can build a runtime binary however you want it. But you can anticipate the upgrade from CPU and GPU will be automatically discovered and get you the boost. And why is it important is sometimes you want to get a server. I don't know what hardware I'm getting. Sometimes I don't, right? Sometimes I'm like doing a lottery. And it happens in a way that this will help you to simplify the applications, unify. Round 2. If you're a gaming developer, you're, let's say, doing something, let's say, interaction, you're sensitive to latency. If you are crunching number behind the scene, you want to get the number out to, for example, you're doing video surveillance. You just want to archive and then track everything here for whatever reason, right? You can do offline, for example, if you want, not real time. You can do throughput mode. You can have latency of a minute, for example, if that's like your use case. Then choosing between these two, oftentimes, if you're a developer, you'll be like, define number of threads, define the batch sizes, define. Never ends well. You can try it. It never ends well. So these come into our mind of, let's say, we provide these needs. Throughput and latency mode. So instead of you trying to figure out how to do multi-streams, auto batching, all the things that sounds like English but doesn't make any sense in any way, we handle it for you behind the scene. And we try and optimize this every day as much as we can based on our customer needs. And if you're doing single stream, for example, we batch it in a way that we want to prioritize your inference so that you're not waiting in a queue. It sounds simple, but that's the Google question all the time. Try to write a double linked list. Good luck, right? Even doing something simple with a timing, race conditioned, name it, you have it. You don't want to write it. You roll it. So again, there's some latency concern. I've heard customers like, but I want my latency to be perfect. Okay, we have a separate talk. But 90% of the time, if you're a developer, you want to get application out, this kind of infrastructure will help you to get your code out without worrying about this. To prove to this point, I have demo, right? You all have demo? Does it run? We're gonna check. Oh man, it's intense. There's so many demos. Have you guys seen any demo yet? All the talk, we show demos. They're all live on this laptop. Oh, my back hurts. So if it runs, let me know. Okay. Yeah. And if anyone interested in this laptop, Dell is our good partner. So please purchase for them. Alienware. Yeah. Yep. You just run the demo. Keep talking. All right. So this demo again, I will focus on just run it, and then people ask me a lot benchmarking, right? How do I know what happens when you're doing inference? Like this is the part where you've done all the fancy NNCF, pod, wherever it takes to get your model perfect. This is the last step to say, okay, now let's think about my deployment hardware, right? So this is an example that you very likely you have to deal with because you want to make sure your customer is happy. So what they're showing here is, go scroll down. Yep, scroll. You don't need to read this. We just downloading the model, converting. I think you all memorize it by now. I say enough, like the whole day. All that. But this is the part. How do I use it, right? Use case scenario. If you are Intel right now, this line of code, if you don't put anything, you don't define your device, is auto. Okay, that's how it is. You don't do anything, it works. Okay, that's what we're trying to do. So today, if you don't define your device today using OpenVINO runtime, this will do it automatically for you. So if you have a GPU, it will offload to it. If you have a CPU, it will find a way to offload to it. But it will offload if and only if it's better in some way. So you may know, why is it not working well? It's not better for your code. We're not doing it, something like that. Okay. Next is if you are like hardcore developer like me, I need control. You see, I drive a manual car. I even define my own auto. So you can define it the way. So guarantee it will be like that. Now, the first thing I want to show you here is scroll. I want to show you how to recognize a dog. Okay, I don't know why I did that. I did that. So I'm trying to show you the running inference with auto is like this quick, right? Yay! I can get like, I don't know, what's the frame per second? Let me do the math. 30? No, 60? 60 frames per second, Thomas? Am I right? No, I'm wrong.
6 frames.
6 frames per second. Yeah, okay. See, oh, I'm tired. I can't do math on the slides. That's how I find. Okay, keep going. But if you look at what happened, no, like those two parts. There's anyone. Go up. I did a comparison. Up, that's down. Yeah. Up. Sorry for that. Sorry, all the scrolling. Where's the second one? Up. There's anyone.
Yeah.
Yeah, there we go. See why this takes so long? Anyone knows why? Now, I use GPU. Why is it so slow? Transfer. Someone's like writing. Still no. GPU is like not that bad. The bandwidth is pretty good. It's compiling. You have to compile the code the first time to run on GPU. Does it make any sense to you? Different architecture. They don't just like, okay, they don't run just directly, right? That's why I said you don't want to do it because we did it. The whole purpose of this is before you actually running code on GPU, there's a process called compiling the kernel. Anyone did OpenCR in their life ever? Kernel, you know? So actually we did all the hard work to push the code there. But there's a one-time penalty to do work. There's no free lunch, guys, there, right? The first time when you push the model, you have to compile the model. It takes some time. Depending on your model size, this can go really high. So we listen to customers like, is the GPU broken? It's like, no, it just takes time to compile. So this is like a workaround, I would say, in some way. But you also have a way to do this faster. Is the second time when you run it, you can cache the model. Okay? So, but to avoid that miserable user experience, when you use auto, it will do it in parallel. What does it mean? CPU, GPU, when GPU is waiting, my CPU is running. It's like a hybrid car, right? You guys, you know, drive a Pierce. Like you have gasoline, you have like, we just keep the electric motor running, right? And at the same time, you're compiling the model so that you actually crunching number the moment you start the applications. And then behind the scene, it will package it nicely, push it to the GPU. But once it kick in, we toggle over. Take the GPU take over, then free up your CPU. So that way your user experience won't suffer as much. Again, it's like a goodie. I call it goodie. It's not a must-have depending on your application. Secondly, I think this one is very important, is you want to have different throughput, right? So for example, you scroll down and then open the task manager so they can see like what happened when you run it or something. Yeah, so you can see the latency here. Let's study this a little bit. I actually don't understand this. When I see this, I thought the whole thing is broken again. Let me explain it. I spent enough time talking to the engineer for this slide, trust me. I was like, what the hell is going on here? Well, why is it like, okay, I'll explain to you.
What do you want to run?
Rerun that code, just the performance one. Yeah, just rerun that. Yeah, and then look at the CPU. So now this thing is like burning, right? It's like going up, right? It's like, whoop, like using that much, okay? And then when it's like doing this right now, you start to look at the GPU. It will switch up. Is it? No? Oh no, this is no, not yet. I'll show you what happened in the performance thing. This is not the auto yet. But like you see the spike here, right? Let's memorize the spike here a little bit, right? And then now it's doing GPU. There we go. You see this now? And anyone notice what happened? I was like, is it broken? No, that's the way it is, right? So this is the part that is spiked up to compile your model. You lower that up. The drop is like, here you go, my GPU take over, and then continue the process. Does it make sense? Okay, everyone's kind of like, I lost everyone again, one more time. Oh, we good. Okay. And that's why the latency kicks in like that. So now if you go here, take a look at here. So this is the throughput hint. So you notice like the latency is like, okay, it's really high in the beginning, and then drop the latency down a little bit, but the throughput is like, boom, right? So basically that's the toggling. All right, next one, latency hints. You don't have to rerun it, but this one, just look at the numbers. You can see what it means. And you can try to run it here if you want, but the key of this one is, you notice like, look at the latency, super, super low. But I don't have that 500, like 600 FPS, right? The reason this doesn't have it is like we prioritize this over this number. And when you're doing something 125 FPS, do I care about 500 FPS? Nah, right? So this is like a very important, like if you're doing 6 milliseconds latency, you're talking about gaming responsive experience, right? Hundreds, anyone play Diablo? Think about pings that's like over 100? It's a pain. So anyway, so these are all the like very important tricks that for you building applications. What it means in general is if you think of this graph, right? If you want to suffer a second latency, that's your application insensitive to that, go for it. You get a lot of FPS, right? You're punching the heck out of it. Or you want to be sensitive, do this way. And this tiny change in the code change the behavior of the engine, right? And that's a lot. It's like a turbocharger. I know, I love car. I know you all love car, but you're like a turbo, right? And if you scroll down a little bit more, this graph doesn't make sense. I think I can skip it right now. More graphs, it doesn't help. Yep. So a lot of graphs. But the last one is very important to you because that actually is to bring home that one line of code that actually you define what the behavior of the engine, you can really dramatically change the output. Okay. And then don't say it's broken because like now you know why it's there. Okay. All right. Is it confusing question so far? I try my best to be extremely clear. What did I tell you when I got my PhD? I was a TA. I teach for 10 years. So if I don't get this message across, I need to go back to school again. Yes, the back.
In the future, we're going to be able to tune in between those two extremes.
I can only hear half of what you said.
In the future, there's going to be an opportunity to tune between those two extremes. So,
like in between,
yeah,
you're one of my customer asked as well. Yes, someone really want to control the latency. So now, new release, I'm gonna say that all the time. In the new release, in the work, actually, we have a fine tuning parameter, like the streams and all that. You can actually fine tune. We actually have that request already, and yes, it's coming up. The extreme happened because we want to cover the broad use case first, and then you are most likely one of the special use case that we're currently working on. I hope you all learned something, part of the brute force, but if you want to go beyond that brute force, we still have more. So I'll go through this quickly, and then you can have a little bit.
Okay, yes.
Yeah. If you already interested in this by now, if you're not, take a newer stake. You can try all the models. Again, I want to do the cell phone trick, scan this and take a look what you have. Does it work? Like this one. Let's try it. So this is the model, like open model suite repository. So the best way to look through this is look at the code if you're on a cell phone and extend it. And when you get up, extend it, you see models. Click on it, then you see Intel and public. And you click on that, you have hundreds of models you can play with. And you click on any of them, let's say action recognition. There's like a sample video or pictures with performance, with everything, input, output. So this is my go-to repository before I do any work. This is where you find hundreds of models. And there's a difference between Intel one and also the public one. Maybe we share a screen on the model open source. The next one. Yeah, I'll explain that. I explain the repository for you.
Okay.
Yeah. I'll go through the slides and then to prepare the model suite. I'll explain the repository, how to find things. When I first joined Intel, I didn't know it exists. After I start using it, I feel like, oh, so many things you can try, right? So what does it have here? You have Adrian here, right here. That's Adrian. You have more Adrian there. That's also Adrian. And we have Paula there. No, that was object detection. That was a human pose estimate. This is action detection, recognition, action recognition. So that's her getting her son to wash dishes and laundry, and she did the scuba diving. That's how we get married. Is it the same?
Yes.
Yeah, she got married. She got proposal on the ground. I mean, underwater. Yeah, and it will know that you're doing homework. So this is the most practical tool once you have kids. No, just kidding. All right, but this is very interesting because the possibility are endless once you think about this. Each of these demo have a lesson behind it. These are all lessons, by the way. We wrote a tutorial, so you don't have to like, why is it there? Well, we give you all the explanations. You have that map. This one is really cool. It's published by Intel. You know Intel Research? Anyone? Intel Lab? Yeah. So you there? You from there? Is the best something? This one? There we go. I feel so proud. Oh, thanks God. Good. Okay, I didn't say it. Okay, he said it. Okay, I didn't know. But this is done by Intel. You know how they did it? It's kind of funny. I think the paper were like watching 3D movie. Am I right? They watch all the 3D movies. Yeah, it was super fun. So what? Let me explain what is happening here. You have this thing here. you have disparity map. I think that's what this is looking at. It's not that map because you don't have the actual information about the camera, so you cannot know disparity. It means like, I don't know how to explain it, the difference between two cameras. Yeah.
Basically, depth of the wire.
Yeah.
You give anything.
Yeah.
It will predict the distribution.
Yes.
Only few networks can do that.
Right. And that's so cool because look at him. He gets segmented from here almost, right? And this algorithm were done by one single camera, right? This is an estimate with a single camera. There's no like second camera, no depth sensor. And if you pair this with a depth sensor, you can have like even more fun if you want, right? And we do have a company that's that I've been saying at Lasonius, right? So they have also shipping depth camera with Vadis. That's OCR. They work with Chinese, Korean, Japanese. What else? English, of course. I forgot about English. I don't speak English very well. So this is real time as well. You can do this on your laptop. Do it from front. And this is from Paddle. You ask what's Paddle? This is Paddle. I'm so proud of the Paddle thing. It's like super good. Any Chinese here? Chinese knows Paddle? Yeah, it's hardcore stuff there. All right, keep going. Huh? You're the student?
Nine.
That's why we're doing it better. Hey, that's I'm sorry, Badu, we love you. All right, get back to this. Whew, my job's hard, guys. All right. No break. No break. We have no time. Sorry. I think, are we okay? We can do Q&A in separate. But let's show you the repository. I want to go through the items there and explain which one is like really cool and fun. And we even talk about NLP, guys. We have like natural language processing. Adrian wrote that demo. NLP, was it you?
Yes.
Yeah. So the question and answering demo, that's from the repository. Make it bigger again, please. 150% a minute. 150.
One more.
Yep. So when you walk through this, I'll explain the repository a little bit. Go up, don't worry about that. Just like go through the actual setup, the models, right? Here, Intel. Stop here or go back, sir. You may ask me why these two, right? What's the public? What does it mean, right? What does it mean by Intel? Here, remember we talked about pod and NCF and all that lovely thing? Yeah, we've done it on the model, so you don't have to do it. Like, see how nice we are? Just pre-do all the work. We got a pre-trained model, that's a name for it. So anytime you say pre-trained model from Intel, that's what it means. And you click on it, let's say YOLO, right? Let's say YOLO.
Okay. Let's see. This one.
Well, whatever, YOLO. Well, the human pose, actually human pose is nice. Where's human pose? Human pose? Human pose? Like human? All these are basically stuff that you can.
Right, there is a question.
Yeah.
Right.
Can hear you. It's a binary, yeah.
Person
Yeah.
detection.
You can retrain it if you want, though. We have a package. You can
Person action recognition.
No, human pose. I'll show you the one that I know.
Human
Just type human.
Control F.
Yes.
HUM. Yeah,
Human pose estimation.
Cool, click on it. So for example, you click on this one. One of them, wherever, whichever. So these are the gigaflop and complexity. So if you want to say go lighter way, you can choose that. But let's compare these two together. 1 and 5, okay? We do it. Like, see, this is 3 times faster. Maybe, I don't know, we'll see. But let's go through this. So, yeah, engineer having fun in the car. I don't know what they're doing with it. But, so that's like, you have all this information that you can preview. And you can know actually where it's coming from. So we're very nice talking about the source. So you can always retrain. Input, it makes no sense to me all the time. I always use someone's sample code. So you always use my sample code. Up to you want to do from scratch. Then we have demo usage, right? If you're like really lost, you can click on it and you have some demo. And if it's not there, we also, oh, that's so cool. Let's have on demo. But we also have this in the notebooks, right? The notebooks is like I would say notebooks is less of everything. It's more like a focus of the fun stuff, like as a demo book, right? As a demo idea. So you can see like this is how you actually get those to run. Go back. I'll recommend you do the notebook first before you go this way, because this is a little bit more setup required. Scroll down. And store all the, like this is it, legal. That's the reason why we have public and not Intel. Public one is like I cannot redistribute the pre-trained model. So you have to basically use the model optimizer, do it yourself for various licensing reasons. Go up. We have a very important one. Click on the, not the README, go back to the repository. Like here. No. Just one step up. Back. Back. Okay, follow my pointer right here. See how I'll do it. But I cannot see it that way. I'll try my best. So here, this one, for example, now this part, you may ask me what is in it, right? The XML, right? Okay, this is all the binary. So for example, if you want to get the FP16 pre-trained model, this is the source. You all see it? Yeah, I think I have to keep scrolling to the right. It's a very long file. But that is how you get your source, right? That's all the binary file and all that is all there. Kind of make sense? So there's no secret. So these are the repository that we're hosting all this work. And you can see from here, you have FP32 and all that. And if you go for this enough, you will find the one with, let's say, innate. The innate one is the quantized one, right? So that is like how you figure out if which one has quantization or not. I think the first one has the quantization already. Any questions so far? And this is a cool one, by the way. This is the one that I really want you to try at home. This is BERT. This one can answer questions for you. You know, like machine learning that you can like ask questions. This is a cool one because, I don't know, that happened again.
It's because of the noun.
Yeah. Anyone did SAT here? You know what SAT? SAT is like standardized American. Am I right? I didn't do it. I'm from Canada, by the way. I don't have to do it. It's a test, right? So that data set just now actually learned all the questions from it, right? And then you can actually try to answer questions. And guess what? It's better than human. Some cool answers. So this is actually very important for you to maybe try because I find it fascinating. So with this pre-trained model, we have the last session. I'm gonna prep you for the last one. Again, we have only, yes.
30 minutes.
Yeah. Yes. Again, I need to really.
Sorry, wasn't the part to follow?
Yeah.
With the link, that models are, that would be great. But I have 4 questions.
Yeah.
One, when you get into Convolutions, there's a part that says, you know, the gender, age, and emotions.
Yes.
I'll reserve that. 2, you mentioned the public models of the so if I create access, you can pay for it.
First question first. You talk about age, gender, sex.
Yeah, it will come as types of the same.
How? So as I
So the
understand.
second question is,
Yeah.
why is in the public model?
Yes.
I mean, I solutions that you pay.
Yes.
Is that a problem?
That's exactly why we put it public, because like you have to look at the license behind it.
Okay.
Yeah. So we very carefully crap out those because as Intel, right, as a company, we have that responsibility making sure there's no infringing of any copyrights, the licensing. The one that we provide on our Intel website, the GitHub, is Apache 2. Apache 2 explicitly talk about commercialization is yours, right? You just have to read the license. And I often, if you're releasing a product, I recommend go for a legal lawyer once. If you're doing business, if you want to do business, you have one review session. I did that for my company before. Every single license that actually doesn't fit, you have to remove this from the redistribution. Right?
And then coming back to, do you have clients who speaks really want to look at gender and age, and they, I mean, because that is a problem in some parts of the world.
You mean the bias is part of that?
Yes, the bias
Yes.
is what they're using for.
Yes.
If they combine age and gender, like crime is very high.
So good. Intel have a lot of ISP work on different type of problem. But from Intel perspective, when I did when I become evangelist here, I would go for a training for the AI ethics, right? So we take that very seriously as a company. We look at like model if there's any biases and all that as much as we can. But internally, we don't have a product that does exactly that, right? we sponsoring our partner to basically handle both of those use cases, right? Like we don't ship software like those by definition, right? We make our partner ship those out and make money, right? But in return, most likely they buy the product, like the chips that we're shipping, right? So that you see the dynamics we have here.
Yeah, yeah.
Like we're helping a lot of product from others.
So us is like to help your partners if they want to deploy something from scratch.
Yes.
Yeah.
Yeah.
But they'd be looking at certain things like age and
It,
gender.
I've seen that.
And
Yeah.
then you advise them on how.
We don't advise that exactly. It's a relatively sensitive topic because different regions have different criteria. Like Europe, for example, you can have him answer some of that. Europe has different criteria about how they use AI. I did a talk about this with BMW group with Robotron recently on it's on the last conference. The idea were we even want to not making people see the face in, let's say, in a factory, right? You want to hide the identity for the people. Let's say you go work, you don't want your face to be tracked, right? So we actually do some of the work as well to even do the opposite of surveillance, anti-surveillance, right? So we just like track the car only, take out the worker spaces, and then anonymize it for people. So there's a lot of work in behind the scenes, and if you have any of that product or anything, definitely talk to Paula, and then we'll help you to see if you put a good message around it. Sounds good?
The last question, are you looking to add more languages to your OCR?
Plenty. So yeah, we actually have, that's why we work with Paddle. That one has many languages already. So if you have a model that already have different, you can upgrade it as well. Yeah.
What's the kind of model?
So the OCR right now is trained on, let's say, Japanese, Chinese, Korean, right? So I'll go back to you, come to me, I'll show you where we get that. It's in our, if you go to the notebooks repository, we can show you the one that we does all this. We have a reference to the original source that you can see it.
So the thing is that maybe languages are ambiguous in the first 2000.
We're, yeah.
Into that project or like just keep it.
So I cannot talk on behalf of the whole Intel about how we position in OCR right now. I heard other companies been helping on that process, but in return, what we're doing is when these are available, especially from some big search engine company, we will be supporting it. You can only laugh so much because like I don't know all the answer there, but I know that we're not working on this actively. Yep, we have last question at the end because sorry about this. She got like an ultimate demo here. This thing will fly. This will
It's not
fire
working.
and
To be serious,
everything.
I need to calibrate it. I didn't have enough time to calibrate it, but I will show you what happened with this baby here.
Yep.
So, okay, so let's continue with this topic. So we talk about different kind of optimization tools, supported devices, how we also are able to optimize and improve the performance with the supported devices. So right now I want to talk about a new tool that OpenVINO, I mean the ecosystem that OpenVINO has create. And this is really good if you are in the computer vision land, because the name of this is OpenVINO training extensions. So we are creating a new pipeline. It's a framework for computer vision. So right now we have PyTorch, we have TensorFlow, we have like a deep learning frameworks. But this framework is a computer vision framework. So this is an umbrella, and we are covering here 6 computer vision tasks. We have semantic segmentation, rotate object detection, object counting, object detection, image classification, and we have also anomaly classification, detection, and segmentation. And this is really, really good because with just one single tool, you are able to train your model from scratch, or also you are able to work, make that task with transfer learning. So I really encourage you to visit the repository that we have. And if you are an Ubuntu developer and you have these requirements, you can install the process and let us know what happened. If you have issues, or just please comment in the repository also. So we have some requirements. If you have GPU, you know, you run the training faster, but if you don't have, it's no problem. You can still running the training just in the CPU. So what is OTE? I'm so sorry. So you want to take a picture of this? Sorry, so sorry. It's fine. So, well, I want to talk about the components that OTE has. So the components that OTE has is OTE has algorithms, and we are talking about several algorithms per computer vision task. So what happened? We are not working with tiny or small data sets as the academy is working with. We are working with bigger data sets, and we have a great pre-trained models. So we have the option to work with that models as a template, and we are using these templates to work with the transfer learning. So OTE also has command line, and this is great because we have different operations there. You are able to train, you are able to create the evaluation, the validation, and also the deployment. The deployment is really important, and I want to keep the deployment at the end, just to explain a little bit how it's working that. But we have also an SDK. So you are able to combine and join the algorithms with the command lines, with the SDK. And the deployment that is important with OTE, you are able to have two things, important things, the model in intermediate representation format, and also you are able to have this model in PyTorch. And you are able to have the deployment code from OpenVINO. You have the example. You will have like an OpenVINO.zip folder when you have all integration and requirements that you need to install, what you need to install to run OTE, I mean the deployment of OTE. And you are able to do that. And this is a great tool. So, okay. So we have three great messages here. So OTE has models pre-trained with a larger images, as I told you at the beginning. It's a simple development interface where you are able to make training, evaluation, validation, and deployment. And also has an optimization with NNCF and POT that I hope that all of you know about those tools today. So, you know, what is POT, by the way? You can get prices. Post-train optimization tool. Yes. And NNCF? Okay, you get prices, so just come. So, okay, great, thank you. So we have, if you have an idea, I mean, you have an idea, you have a new project, you have data set, you need to have the data set annotated. Also, you are able to use CVAT create annotations. That is also an OpenVINO annotation tool. So with the annotated data, you could select the model from the templates in the list that OTE has. And then you are able to train your model using OTE. I will show you that in just some minutes. And then you are able to compress the model with POT or NNCF. So, and this is just like a mix of everything. And also optimize the model with the model optimizer and convert this model to have this intermediate representation format. And at the end, you have the deployment running properly with the intermediate representation format in every single Intel hardware. So I have this crazy idea. I wanted to go to the supermarket and make like an automatic checkout. And okay, I can go to the supermarket and buy the vegetables and fruits by myself and just make the training and test OTE. So this is the thing that I made. I create an object detection task. I was using that. So let me show you. Okay, thank you. There, yes. So I have here object detection. So I have here the initialization. SDK is initializing everywhere. Also the command line that I told you. So we have here the register templates. In this single command line, you are able to see all models that we are supporting. We have different models for segmentation, instant segmentation, object counting, so all things that I told you. And I'm selecting here SSD. So, okay, this up. SSD. I'm selecting SSD. And I'm using this constant object detection Gen 3 SSD. And I just charting here the default hyperparameters. But I need to check if I have hardware to run this, for example, the bash stats. So here the default, let's see. So, and I need to have the data set and the annotations. So depending on the task, you need to have the proper annotations. But in this case, I'm just coming here the proper JSON files. And the bash, the default bash, for example, is 10, and I needed to change that to 2 because I didn't have a huge GPU. I needed just to change that. And then I was creating tasks. And when I create tasks, I create the environment, calling the hyperparameters. And then I'm able to run the training, just calling the command line train. This is simple. This is one also the key messages that we have with OTE. It's a friendly tool. You don't need to know anything about that. You need just to run the command lines. So also we have here in the training, we have also a tool that is able to evaluate the matrix of the model with the data that you already have, because you need to switch the data between training and validation as a simple computer vision task. And then you are able to export the model. And when you export the model, you create this intermediate representation format. But also, you are able to create the exportable code. The exportable code has the requirements that you need to install to run your model in every single system. So that is the idea of OTE. I hope that is clear for you. And do you have questions about OTE? I need to jump to another topic.
OTE is hard because you need to make sure you install all the requirements, okay? But it's a good package that if you want to start from scratch, retraining something. I did a demo on this a while back. I was working with the engineers. We basically retrained the model to do text detection. You know how you write something on a piece of paper? And pre-trained it is like, sure, it works on Ferris handwriting. Then I use my doctor's handwriting, which is scribble that you cannot read. I retrained it using this tool. Then voila, from let's say 60% of time, it's saying that I'm writing my name. You get about 80 and 90% with, let's say, only 20 images or 30 images I put in. So that's like the time that you need to retrain sometimes. Always, I'll say in your life, you always, if you're doing this job in your life. So this will provide this package for you to try. And you can see from here, Paula actually spent a week at a supermarket to find all the fruit to train.
And I went to it.
And she ended up eating a table of them. You only see a portion of it. I saw a photo. What happened? It's like, what happened? What happened to my budget?
That wasn't my budget.
Just kidding. I was kidding. Oh, you did? You should expense it. All right. So we work here. What's next?
Anomaly.
Anomaly. Let me help you introduce. You look tired. All right. Anomaly is, yes.
You mentioned that
It just, yes.
So you that's only for training or
Training only. Training. I gotta emphasize that Intel does inference very well. That's how I got my job, because it works very well. When I joined, it's amazing that I can do a lot of inference. All right, so I'll help you introduce the anomaly. So I'll stage you up. Are you ready for those?
No, I need to, okay, yes, I need to show here also another demonstration.
Okay, you want to set it up? You want to set up?
Set up.
You set up? Wow, she's amazing.
No,
All right. I don't want to hype it, but let me explain what's the next step. All of you heard a lot of tools and all that. This demo to show you how hard AI can be for your life. She didn't sleep, I didn't sleep, we didn't sleep because of this. And because this is an end-to-end demo from capturing, training, what else do you do? Many things. Evaluation,
and deployment.
and then, well, not only that, optimization, deployment, control, and dumping this little thing. All right, like nothing here is easy. And
It's
you see
not working,
robotic
it's just
arm?
making the calibration, so.
It's calibration. Yeah, let her be. And if it doesn't
Don't-
work, that's okay. If it
Don't be
works,
so excited.
yes. You know, the reason we're doing this is want to show you that in every part of the journey, we have something for you, right? To prove this point, we built the whole thing from scratch a month ago, 2 months ago, 2 months, maybe. Yep. So that's how much we love CVPR. It's organized on the fin. Invite us back next
I
year.
do like more.
All right. Before we start there, anyone know about anomaly? Okay, make it simple. Do you know what an anomaly is, right? Like when you have an image. Okay, I'll give you a use case scenario. You are making candy, you're a candy factory. And your candy is supposed to be round. Okay, it's a dumb example, but it's actually a real example. And then every time you have a bale of candy, the not round one should be not shipped because I expect my candy to be round, but how come turn you a triangle? I don't want that, right? So in machine learning, computer vision back then, people do it a little bit differently. They use like, draw a contour and all that. That's an easy case, right? You can say, oh, this one's not round, discard it. What if they're potatoes? What if you have apples? When you having this use case is getting more complicated every time. We build from scratch. Are you gonna do something dramatic?
Just test.
Okay.
But it's not working. I mean, I know that it's not working, so.
Oh, it's not working. So we have a non-working test right now.
It's not working test.
So we'll pick up a cube.
So let me explain you. So we have holes in the cube and we can select, we don't have enough defects in the data set. We have a lot of goods and we don't have enough defects. So the idea with that is the camera is taking the picture and I was running anomaly before that. And that with that, we are able to see what happened with the, but in this moment, it's not working. So
Are you
it's
showing
wrong.
something?
Yes. So the point is that.
Debug in the camera.
I don't know, it's fine. So the point is that I work with this environment, I mean, this robot in Windows is terrible. Don't do that. So I have a lot of, because I wanted to have my 12th generation running with the anomaly and also the.
Should I plug it back in for you?
Okay, I think that I have a problem with the computer. I have serious issues. I mean, I think that it's a virus or something like that.
Yeah, but.
So the point is that we have different objects. I want to show you the demo. I mean, the demo in the notebook. I think that I'm not able to show this demo today, but I want to show you a video. So just let me show you what is the concept of anomaly in general, the components that I have there, and how we can use anomaly for different kind of things, not just for factoring, also for medicine. And I think that this is one of the challenging things that we have in AI with computer vision, is that we don't have enough data. If we don't have enough data, we have problems because we don't have a good models. Anomaly is giving us the hand to manage that.
Well, to back up this scenario, let me show you the slide to how it'll look like when it's working. Don't worry. And you can still try to unplug it back in and show one last time. All right, so before we travel, we put it together. Let's go to the demo and we'll go back to the slides, okay? Yep. So
let me stay with you.
yeah, we'll come back to that because like.
Let me explain them.
Yeah, you explain it. Come right after. Is it me?
Yeah, it's
you. It's me. Okay. Let's look at what happened. Okay, because you're prepped for this.
That video is no good. This is my disaster in my home.
Yeah.
So I have
So
like an airplane with paper there, my glasses, my headset.
Are you ready? Are you ready? So this is. Let me explain what happened here. This is a home doing it live. You can see the background cluster.
Don't show the mess.
That's perfect. It's color proof. And the idea is like you want to pick up a cube that actually doesn't have a hole. So these are the holes, right? So that's what happened in live. Let me do it. Can you do it for me?
I can pick.
Yeah, click it for me. Click the play button.
Yeah.
Yeah. So what happened is it's playing right now. Oops, I don't like it. Boom, drop it. So the idea is like she trained a neural network to understand what is the abnormal part of, let's say, a cube. Let's say this is an apple, for example. Nah, you don't want an apple with a hole, do you? I don't think you ever want to buy Apple the whole. Then the idea of this is like, okay, if any time it sees something that actually not fitting to the criteria, the algorithm is quite simple. You train a network, look for things that actually have a heat map of, let's say, bad stuff. And the camera will make a decision with the brain, or say the brain is a neural network to say, okay, this is not good enough, and make a decision and drop it. The reason it's slow is it's not the camera is slow. Well, it's not the camera, it's not the algorithm is slow. We're doing it slowly to demonstrate this. So you can run this like 100 frames a second, maybe 100 of this, and then keep dropping them, right? And what am I supposed to do here?
Let me share my screen.
Oh, it worked. So this is the moment that it will not like, I don't want to, like, that's where you lose your money, right? You want to drop that cube or you want to ship it, right? Can this be good apple, bad apple, good potato, or bad potato, right? And you train this neural network with all the tool you learned today to do this, and she's brave enough to try again. And that's what we're trying to do. Are you doing it?
No.
No, okay. All right, but that's idea.
I want to show you another thing with anomalies. I think that is very important that you know
Right.
maybe how is working anomaly, how you can work with anomalies. So
Yeah.
this is, you can also see this demo maybe in the happy hour.
Yeah, we're doing it again. Okay.
So we will try to show the
Awesome. Well, in short, I think this kind of demo, we put a lot of heart into. Think about the user, right? If you're, let's say, building a system like this from scratch, we tested that most likely you'll get support. All right, that's it for now. For there, you want to go back to what the anomaly is and explain to the audience a little bit there?
Okay, so.
Yep. Okay, go back. Here we go. Can you help on the back if anything?
Okay, so anomaly, as Raymond mentioned that, so I just want to bring here, I mean, the idea. It's similar pipeline that for the OTE, no? So OTE is also, the foundation for anomaly detection, for anomaly classification and segmentation is in the anomaly. So OTE is using anomaly to do that. So the point here is that we have an idea and we have a data set. What is the difference with OTE? We don't need to annotate the data set. And this is a big challenge that we have here. So I can say, this is good, this is bad. This is the simple annotation that I can do with that. And I will tell you my experience. I was working with 5 cubes, good cubes, and 3 with anomaly. And I trained the model. And the model was working perfectly at that time. Just with 8 cubes, I create a model to detect an anomaly. That was really good. It could take me maybe 10 minutes, just making the setup of the camera, and that's it. So running the notebook and the information that Anomaly has is great. Anomaly is another tool that the OpenVINO ecosystem has. And it's a well documented, so you can go there, you can go to the OpenVINO toolkit organization in GitHub and find anomalies. Also, you can take a look at the QR codes. So, sorry. So also we have here the train part, the testing. So we are providing also test tools. And also we are working with training and optimization with intermediate representation or OpenVINO format. And also we are able to create the deployment part. So the components that Anomaly has is that we have around 10 algorithms to work with anomaly detection. And that is impacting mainly the industry, because these kind of things are mainly in the industry, but also in the medicine. We don't have a lot of patients with illness. We don't have a lot of defect objects in the factory, in the process, in the production system. So we are using right now a lot of 10 algorithms that we are able to work properly. Modules. So we have different modules, and the meaning of that is that we are able to work with different modules are dataset. And this dataset is just one single module. So you are able to use that module and you can connect with another kind of things. The modularity thing that is one of the advantages that Anomaly has. We have also the models the pre-processing part. So if you have like a huge image, you are able to tile and just create like sections of the image, and you can do that in the pre-processing part, and you are able to make the inverse in the post-processing part. That is another module. We have the models module that are working with feature extractions, and we have the train module. So we are able and you are able to work with different modules independently. You can make the things that you want to do. The modularity that the library has is great. So the next is the tools.
Is there any constraints of the data set? You said that you trade with 5 good, 3 bad. So is there any constraint that is there a homographical constraint that only that object should be there, or it just works around the walls?
So it depends. So for example, in the industry, you have it's like a regular scenario. It's just changing one little thing. So
okay, so it has that. It should be that particular, not too much homographical.
yes, for example, in anomaly classification, that is the case. Okay. For anomaly segmentation, you need extra annotation. So in that case, you need annotation, and you can change the scenarios in that case. But this is maybe the scenario for the medical images. For the factory and the production lines, you can see more the same scenario, just with little changes. And the tools. So we have the train tool, the testing, the validation. And you are able to work with, so we have the train, we have the testing, we have the optimization tool, and the deployment tool. So we have these 4 main tools. So the great point here is that this library is working, the foundation is PyTorch. You're able to work with PyTorch Lightning. And the train is working with PyTorch Lightning, the testing also. The optimization is working just with OpenVINO. And the deployment, you are able to deploy your model in PyTorch, Onyx, and OpenVINO. So you have a wide range of possibilities. And this is also good. So, and the next, the last part that is the most impressive is the deployment. So, because as I told you, you are able to work with this. You have the flexibility that is one of the advantages that Anomaly has. So, okay, you saw let me show you the demo. Let me show you the code. I want to go to the.
You're brave enough to do it again, huh?
Can I share my screen?
So we have demo code behind it.
But I want to show the demo in the notebook.
Yep.
So let me show you first this one. So.
Share screen.
Oh, yes, it's your screen. Okay, so.
We're running it.
Okay, so.
It's okay to crash it. It's okay. We're doing it live, guys. Right? But we'll show you all the processes behind it. Because she's debugging on the hardware level mostly. It's a new hardware.
First I want to show you, so we are working in different benchmark data sets. So I don't know, do you know MBTech data set? This is a benchmarking data set for industry. If you are working in the industry or you have plans to prototype anything, I really encourage you to visit MBTech, and they have a great data sets. So in this case, I would want to show you here. So we are working with PyTorch Lightning, as I told you. And we are working with these modules. So we have data, the models, the pre-processing, the models, the modules that I told you. And in this case, we have here 7, but we have in the repository 8, 10 algorithms that you can run for different anomaly tasks. So classification, detection, and segmentation. So you need to configure, and this is the core of anomaly. So here we are setting up the modules. So let me show you. We have here can you see it? Or
yeah. Oh yeah, one more minute.
1 minute.
Oh, a minute. Okay.
Yeah. Get to the meat.
Okay, so you have here the modules, data set. So for example, in this case, I'm working this demo. I have a cubes, and I have a folder. This is the format that I need to use, and I have this data set cubes, the data set that I made. So You have here a lot of information, so you can just come here and see what kind of things we have per module. So we have the model, the metrics, the projects, so the optimization. When you want to optimize with OpenVINO, you need to apply this through. And okay, so you can see what happened with that. Let me show you. So we have the validation, and we have here the results.
Yes.
So-
Isn't that cool? You find where the heat maps.
So in this moment, I mean, this information is not really good. So, I mean, maybe the first trainings that I made were better, but this is not because of anomalies, because of the problems that I have with my computer. So, but normally the anomalies is more than 60% in these cases. So you can see here, this is anomalous with a 56% of confidence that is anomalous. And we have anomalous for all. This is a normal piece. And the point is that I can create just a score and check the score. If the anomaly, if the confidence is higher than 50%, it's like an anomaly. And I can put the cube out of the conveyor belt. That is the point. This is a single classification. And the point is that I need to split the data set in between abnormalities and normalities. So that is the unique annotation effort that I need to do. But let me show you something. I mean, this is really cool. This is an anomaly segmentation. So this anomaly segmentation is coming from the data set that I told you, MVTech. And we need to have here the annotation. So the annotation of the area that is, we have the anomaly there. And we have here also the heat map where the anomaly was detected. So, and this is great. So this is coming directly from the anomaly detection. So this is the result. So you can see here. So we have the ground truth, we have the image. So this is a bottle. We have if it's good or bad, if it's breaker or not. So we have the ground truth, we have the predicted heat map, and we have the prediction mask. And this is really good. I don't need to use. I was spending maybe 1 minute or less than 1 minute, I think, in order of seconds to train the model. And this is impressive. I really encourage you to visit the repository and go there and install Anomaly and try yourself.
Good. All right, we're gonna wrap it up.
Show you.
Hold on.
Okay.
Wrap up. All right. To find out more, you know my contact. Let's go through the closing very quickly.
Yeah. Stop sharing. Oh.
Okay.
Yeah. All right. All right. For all the audience, well, you saw it. Well, you're the 1% today. If you forgot, no, 0.1 of the 0.1, right? Something like that. At Intel, when I joined, I think that's the reason why this is like not popular enough, because it's such an amazing tool on your hands. If you can turn this into 10%, let's say you teach your friends again, learn, let's say, well, Intel can do this AI stuff, you can teach the next person. This will change the whole dynamic of, that's why I'm here. We're doing research, right? The whole point of research being successful is someone else use your work. Having this in mind, having that maybe not 1% of us, 10% of us, let's say, especially I have a professor I heard here. Am I right, professors? I'm very enjoying talking to all of you about this tool. And hopefully one day you remember what happened today. I hope 10 years from today, you say, I'm the 10% now, right? Yeah, I'm making the difference. Take away. If you don't know what's OpenVINO today, give me I'll scream my heart off. No, that's okay. If you don't know what's OpenVINO by today, you're not taking my joystick. All right, you have to take it. All right. Is it easy to use? 6 lines of code. Come on, right? But the detail is the devil, right? I'll give you all the devil today. It's hard in some way if you don't know what you're doing. But we've been teaching you what you can do with it. So hopefully you're not like empty-headed. Like I read too many tutorials in my life to don't understand the thing, right? So it's always best to have a teacher. So my job as a teacher, Paula was a researcher. We have actually other teacher teaching this. Go and learn it. I show you all the way I can optimize something. So you don't have to do this for the next 10 years of life, okay? I spent 7 years optimizing code for my PhD. So I did GPU, I did FPGA, I did everything I can. You can look at my thesis, I'm not joking. And at the end, I built augmented reality headset for a reason. It's too hard. I want to do something I can play. But optimizing doesn't mean you always sacrifice. It's trade-off, right? You can trade the way you need it for your use cases. And I show you brute force at the very end, just buy better hardware. Xeon server is coming up. This great graphics card is coming up. Brute force will work if you want to just like utilize the best hardware, you can still get your way in. Optimization, don't look somewhere else, look here, right? This is how you get your best of the hardware. In the discrete and Xeon use cases, hopefully you all like me enough, keep voting me up in some way. I'll come back next year to talk about those new hardware. You want to learn how the new hardware works with OpenVINO? I'll be there for you. And lastly is, we are not just doing inference, there's some training involved. We are crazy enough to put this together for you with the whole demo kit that Paula did. And you saw it working before the shipment. You can see shipment with hardware. Nightmares. We know. We will make it work again. So it's not a big problem. But with OTE, the OpenVINO training extension, and normally all this library ready for you for free. Apache 2. No strings attached. Stay connected. I still don't know what this is doing. What is this?
You can connect with us and find our links in LinkedIn and how you can connect with Intel, the newsletter, and how they can see.
It's an everything link. Let me try it.
AI certification program.
All links.
It's an everything link. So this will help you to stay connected with us. Our contact is there. All our evangelists from PRC. It's a one page of summary. And if you want to contribute, you want to be not my student, like be my mentor as well. Come and talk to us, okay? Are we all done?
I also wanted to show the Dev Challenge website.
We have a Dev Challenge website here.
3 slides.
Oh, 3 slides. I'm not done. Yeah. Okay. You guys know what I'm doing, right? I did marketing for Intel, but I'm an engineer. Okay. And if you get a T-shirt, you can say to everyone that I wrote that code with Stephanie right here. Stephanie, make that happen. I wrote that code. All right. The very end, we have Dev Challenge. Can you tell us like what's Dev Challenge?
Yeah, so what you learned today, we have a certification course that teaches about OpenVINO. And so it's great for anyone who's new to this. It's the other
Come
website.
this way. There's a camera here. And
Right, camera.
then you can win a laptop.
It's the other website.
The other one?
There's 2 links.
Okay.
But this is the AI dev team adventure. So we created some really fun videos. There's one with OCR. You'll see Ray and our team on there, and also object detection. We tried to make it very interesting. And then this is the 30-day AI dev challenge. So it has different modules in it. So Adrian, can you scroll down? And then in it, you can actually get a certification badge saying that you're officially certified with OpenVINO. And then so we have prerequisites, and there's a section on retail industry, and then another one on industrial use cases, and then cities of the future. But we also have a medical devices portion. And then if you complete this within 30 days, you'll be entered in a drawing. So you can this is a high-end gaming laptop with one of our teachers. Probably you got one already today. And then if you scroll down, we also have a bundle of different fun, different game titles, as well as some art things. So there's hoodies and backpacks and all kinds of fun things. So this is a program that will be going on for the rest of the year, but we're going to pull it every quarter. So there's some prizes. So let your friends know, let and spread the word.
Yep. And the Kaggle video. Yeah, I'm a superstar now. Thanks to her. No. You see us like on.
Can you play the other one? You go to Kaggle.
And
So that's gray, the one in the orange.
Look at me. In Japan.
So yeah, we could play the teaser for a second. It's really fast. Let's see if it works.
Here. Anime. color is on the next step. New source code I wrote down, by the way. Info. Oh, sure, not easy. You can check how. That one is landmark to chart.
Thank you.
Thank you, everyone. And thank you for the virtual audience. And you can watch the recording tonight again if you really missed me. After that, we have all the swag. Everyone stay till the end. Feel free to grab as much as you can. So,
As much.
That's much.
is there something wrong? Okay, Stephanie will handle the shopping. But line up, please. Don't fight for it. Everyone should have something. If not, then Stephanie will handle the rest. And then any questions, you can come to me. Yes.
When I use try to solve more stuff